Hello, welcome to another stream. How about that? How about that? Bet you didn't expect that shit to happen. Hello, Mr. Botka, I good Sasalala, Mr. Botka, Hamikovi, I good I'm inherently bad, I'm inherently bad. Nerdy BHU1, Heroes and Bloods, Yatanasov, hello, welcome. So, today is Monday, if I'm not mistaken, and that means today, according to the schedule, we're doing a virtual machine in C, and also a low-level language for that virtual machine. Hello, Nichik Slice, hello, Life, hello, Lazy Grit, welcome. How are you guys doing? So, yeah, today we're gonna continue developing this thing. You can find the source code in the chat. If you're interested in it, it's completely open sourced, and yeah. So before we get started, I think I need to make a cup of tea, chat. Dead projects. I hear the voices of dead projects. Well, they're not dead, they're paused, okay? So they're paused. We don't have dead projects on Sodium channel, okay? So we have paused projects. That means we're gonna finish them eventually, right? All of the projects on the Sodium channel are gonna be finished eventually to their full conclusion. Trust me. Anyway, so we need to make a cup of tea. So Yisu, kawai desu. So we have French press. Yes, I brew my tea in the French press. Sue me. What you gonna do about it? Can do shit. I do whatever you want. Whatever I want. It's a free country. God damn it. If I wanna brew my tea in the French press, I'm gonna do that. I'm gonna fucking do that. See me doing that. I use the French press as well for tea. I don't know, for some reason this weirds out some people. Yeah, so you can use French press for both making coffee and tea. Apparently some people didn't know that, and apparently there's a lot of them. Yeah, so you could do that. Especially if you don't have a teapot. I don't have a teapot. I literally use a French press as a teapot because, by the way, this French press is actually pretty cool. It's very small and it's literally 1 cup. So yeah, it's perfect. I love it. Anyway, so now let's go to the BM. So what do we have here? I have a BM upgrade, something. Do I have any garbage in here? Let's fetch the latest stuff. So I'm pretty sure we have a couple of pull requests to the virtual machine, so that we'll have to review. Utah teapot when? Well, I'm not in Utah, so I won't be able to buy it, but maybe I can order it. Not sure if it's easy to order things from US in here, but maybe, I don't know. I don't really care that much about this kind of stuff. It's just a teapot, you know, just a teapot. But maybe it's also a meme. Maybe it's also a little bit of a meme, if you know what I mean. Okay, so let's actually bootstrap the build system, the no-build system. So we build our projects purely with C. And let's see if everything works. Everything seems to be working. What if I do a test? So test should pass as well. Cool. So now we can even try to maybe run some of the examples. So the thing that runs the examples is called BME, so it's a virtual machine emulator, right? And we can run, for example, Fibonacci. So one of my favorite examples. And it does in fact generate Fibonacci numbers. Perfect. So let's take a look at what we have today. Interpreter. Okay. So BM. It's a little bit hard in here for some reason. I don't know why. Okay, good. Alright, so I have this as a reminder to update my contribution policy. So also there is something in no build, and I read already about it, but I haven't done any actions, so I'm gonna keep it as it is. So here is the pull request from Nico. Alright, I guess he decided to remove to do. Okay. So yeah, I didn't have an opportunity to answer to that, but I mean, if you If you want to remove that, let me quickly answer it. Yeah, it sounds too vague. I'm just afraid that after some time we won't be able to recall what it was about. Neither it is a very important issue. Imo. Alright. So let me approve whatever we have, and I'm gonna just merge all of that. Finally, we have all of the pull requests addressed. Done. Looks good to me. Thank you. Oh shit, yeah. I forgot to mention that. Thank you for your contribution. Thank you for reminding me. I'm such a rude person. Just a second. Oh my god. I wish GitHub was a little bit faster, but it's getting slower and slower like every day. It's just painful to look at. Okay. And now GitHub doesn't show me. Yeah. Is that what it was? Like, I wish it was actually sorting them in order as I close them. Right. So because sometimes that's exactly what I want to see. Like, I don't want to see anything else. Maybe I can sort that, but I mean, it's additional action. Whatever. Doesn't help anyone. Thank you for your contribution. It's annoying interfaces all over again. Alright, so let me fetch the other stuff. Git fetch problem. So let me sip my tea. By the way, I bought more Earl Grey today, so I ran out of my Earl Grey recently. So this is a new fresh bag of Earl Grey. So hopefully it will last me for at least a week, because that's how long they usually last. So, and hopefully that's gonna be a fun week. Earl Grey, yes. Cheers. Going outside, interacting with people. Didn't interact with people too much, to be fair. Alright. Merge origin master. Okay, so let me rebuild everything. I think no build was not affected, so I can just rerun this entire thing. And everything looks okay. Do we have anything interesting to work on? Include directive does not report location if the file does not exist. This sounds interesting, and this sounds like a pretty cool warm-up to get back into the context of the project. Right, so we have different directives for our translation engine, for our translator, I guess. Different directive for our translator, because the source code in Bosom assembly for our virtual machine looks roughly like this. Right, and it also has different directives, and those directives are not pre-processing directives. We didn't make the same mistake C made how many? 50 years ago already, right? So C was in 1970, so it's 30 years until 2000, and today is 2021, so that means it's like 51 years. So C made a huge mistake 51 years ago by making pre-processing and compilation two separate steps that cannot really share information between each other. Well, I mean, preprocessor can probably pass information into the compiler, but it can't receive information from the compiler, and that's a huge mess. It's a fucking huge mess. We didn't make such mistake. These kind of directives are part of the language, so they affect the context of the compilation, and they can extract information from the context of the compilation, so they are more powerful and they are more interesting. So, but of course they are not fully implemented. For example, if you try to include a file that doesn't exist, it will just tell you that cannot open this file, but it doesn't tell you where exactly you try to include that file, which is the most interesting information. And the reason why it is doing like that is because of the flow of the function that reads files. So let's take a look at the function that reads files. The function that we use to read files is called slurp file. Right, it's called arena slurp file. What it does, it just takes the file path and reads the whole file into the memory and presents you as a string view to parse and to analyze and do whatever you want to do with the contents of the file. So the thing about this function is that when it fails unrecoverably, right? So if any of the errors happens during reading the file, it just crashes the whole program, right? And for proper reporting of where the error happened, you need to recover from this error. The reason why this function does not recover from this error is because at the early stages of development, that was not needed. You see? So usually how I develop things, when I develop things, basically, if I encounter an error and if at the point of the development it's not clear how to handle the error, I just crash. So, and just makes the development at the early stages very fast and very easy, right? So, yeah, like we don't know what we want to do here, let's just fail. At some point of development, we start to realize, okay, so we want to recover from that specific error, and only then I make the error recoverable, right? So I do not implement things that are not needed at the moment, I implement them later. So, yeah, that's pretty much the thing. That's pretty much the reason why we even have this bug. Right, so it speeds up the development a little bit. It speeds up the development. Anyways, so let's just make this error recoverable. Does it make sense? Does it make sense? Sounds good? Hopefully this sounds good. Let's go! Ooh, I'm sorry, holy shit. So what we're gonna do, what we are going to do, I'm thinking what? We can return the result via the parameter. Why not? It could be something like a string view and the content. And for example, here we can return a code that indicates that something went wrong. Right? So, and what's funny is that in majority of these situations, like we just you know, crash saying that couldn't read the file, so none of these error messages are actually particularly useful anyway. So essentially what we can do here, we can just do return -1, return -1, here we can also do return -1. So could not allocate the memory is actually rather interesting, and I think right now you don't even need to handle these kind of situations, because if you cannot allocate memory, it will just straight up crash. But maybe in the future, as we implement a more powerful allocator, we'll need to be able to handle this kind of error. Right, so, and since we're going to be using like allocator that uses malloc to allocate new pages, so I think it would make sense to just rely on error no in that particular case. The reason why I just return -1 is that because I will expect the user of this function to just look at error no to figure out what exactly happened. And in the future Arena allocator, I think will use error no to report errors, so it's going to be okay. So, alright, so all of that is just -1. And let's see how less usable this function will become, right? Because now it doesn't immediately return you the thing that you want to get. It will return you like through a pointer. So you first will have to set up this pointer, and yeah, it's gonna be kind of. I think you can go the other way around. You can return the content and have the failure variable be returned via the argument. So that could be another thing which will make it easier for you to ignore that problem. But at the same time, I don't know, maybe we can have two versions of this function, right? So this is the first version. The second version would look like this. See what I mean? So basically the same as the previous one, but it also, to be fair, this kind of function would be easier to extract in the future, wouldn't it be? Because then you can use something in conditions like this, right? So then you can have file path, you have a file path in here, and then you would have something like OK, and if and OK, right, something, I'm not sure actually. So right now it's probably something like this, right? String view content, right? String view content, and then you can say if OK, you process the content. Otherwise, report error, right? Something like this. But at the same time, absolutely symmetrical situation would be like this. Int, yeah, you would have to define content like this. Then if arena slurp, arena file path content, otherwise report error. So the question is, which one is better? Which one is better? In this particular case, you would have to define actually two variables, if you think about it. The first is more useful if you want to return more things. If you want to return more things, you just accept more output parameters. So the question is, which one is more ergonomic? I think this one is more ergonomic because it does not require like additional intermediate OK variable. In this case, you have to have two variables defined. Yeah, I think I'm gonna stick with this one. I think I'm gonna stick with this one because, yeah, it just requires less additional variables. Yeah, I also think so. Exactly, like it's just like two variables in here. It's just not particularly convenient, and this one is more convenient, more ergonomic. Okay, so I think I'm gonna go with that one then. So I think it was kind of important to analyze this kind of stuff. So in case of an error, we never touch the content, right? We never touch the content. But if everything was okay, we do the following thing. It's going to be content. Oh, and it's quite important. We also will let a user an opportunity to actually ignore the content. Maybe you want to read the file and see if you can successfully read it, right? But you want to discard the content. So you might as well actually do it like that, which is kind of dumb, but I mean, I guess if you want to do that, sure. So count is going to be equal to n. Hello set 6969. Hello, hello. Content data is going to be buffer that we just allocated from our allocator, and then we're going to just return 0, right? So we're going to follow the convention of C standard library. Alright, so we updated the signature of arena slurp file, and I also want to update it here, so in the declaration as well. So let's just go through the compilation errors and see in how many places all of this shit has been fucked up. Sorry. Okay, so no build. Okay, it's already fucked up in a couple of places. Yeah, that's what I'm talking about. So Bosom translates source. So yeah, this one is actually kind of interesting. So translate source already accepts input file path, but we use translate source. This one is interesting. So, and we also have input file paths. That's kind of not enough. That's kind of not enough. We also need information from where all of that shit was included. From which file. If you know what I mean. Essentially, okay, we can do something like this. Sure, why not? It's gonna be like this, it's gonna be null terminated. And the original source has to be like this, sure. And if less than zero, we're gonna do something like could not read the file, right? So how do we fail? We fail usually like this, std error could not read file svfmt, right? svfmt, and then we're gonna put an error like this. Svarg is input file path, and the reason is str error null. There we go. And then we can just do exit one. But the problem is that we still don't know from where this entire thing was included, right? We just don't have this kind of information. We can add a bunch of hacks, essentially pass the included from information as a parameter. But the problem is that this is a user interfacing function. We don't want the user to provide this kind of stuff as null all the time, and we don't have a default parameters in C. So this kind of information could be put into the bosom context, similarly to how wait a second. Similarly how we keep track of the include level, which is not particularly bad idea. So initially include level is 0, and you know what? That's actually pretty cool. Include source. Yeah, that's actually... Wait, that's actually pretty cool. So essentially, if include level is 0, greater than 0, we know that the fail happened during including something, and we can reach for include source, and we can use that as a... Yeah. That's actually perfect. Include file path. I'm gonna call it like that, include file path. So, and where is include level? So here we update include. Yeah, so here we update include, then we continue, and then we decrement include. And both, what's up? What's up? Welcome to the stream. How are you doing? We're developing our low-level programming language in C. How about that? So we're trying to make the include directive report the problems appropriately. At least. Okay, so let me see. What's interesting is that we need to save the previous include. So it has to be something like this: string view saved include. Actually, low-level programming language? Well, yeah, depends on the definition of low level. Right, it looks like this. Does it look low-level enough? But it's assembly for our virtual machine, right? Which will eventually also compile down to native code as well. Depends on the definition of language, yes, exactly. Depends on the definition of definition. Yes. Alright. So saved include, and we're gonna put this here, include file path. Okay, we're saving it, and then we're setting include file path to I forgot the name. I think it's just called source file path. Input file path. For some reason it's called, that's what it's called. Input file path. And then saved include. Low level in which language that's architecture specific. Well, it is architecture specific. It's specific to the architecture of the machine, of the virtual machine. Lembakote, what's up? Hello, hello. Look. Struct BM. Here is the state of the virtual machine. Virtual machine has a stack. It has a memory where it stores instructions, and it has a memory where it stores like native functions and a static memory. So essentially, right, instructions actually reflect that, right? You can push on the stack. You can you can call other functions that call native functions. You see, it has an architecture, and it has architecture-specific language. Yeah, you can even look at them side by side. So it's a low-level language. It's a good definition. Thank you. Alt9, what's up? Hello. Shouldn't I be doing laundry? No, I shouldn't be doing that. Thank you so much. That's why engineers will laugh at you if you say CLO is low level. Yeah, it's actually quite high level because it hides a lot of architecture specific stuff from you, like shit ton. Like holy fuck. Yeah. A lot of developers these days think that C is a low language because they were told so, right? So anyways, so what do we have here? So where is the translation? It's gonna be Bosom translate source. I think it should be called Bosom translates file because yeah, that's exactly what we're doing here. Yes. So it's also recursive. I can find shit in it because it's so huge. Translate source. There we go. So this is basically what we do here. I might actually want to kind of enclose it into a scope, right? So to make it a little bit easier. Saved include, blah blah blah, and everything seems to be working correctly. So now, when we are reporting an error, essentially we need to check two things. If bosom include level is greater than 0, right? That means we the fucky-wacky happened inside of the include, and we know the source of the include. And the way we're gonna actually do all that is so let me think. So we have a file location, right? So we have a file location. File location is actually defined somewhere here. Oh shit. That's very interesting. Huh. So that means the include location should be a file location. That makes more sense. The reason is manual memory management. So the reason of what? So here is the common mistakes of younger developers or developers who's been working with quote-unquote high-level languages. They think that manual memory management is at the bottom of the abstraction, and then you have garbage collector that is on top of the manual memory management, and it quote-unquote solves the problem of memory management. Right. They keep thinking like that until they encounter situations when their garbage collected languages suddenly starts to link because they don't zero out particular references. They also keep thinking about that until they realize that the garbage collector doesn't trigger at the right time, so they have to trigger it manually. Right. So, in fact, this kind of thinking does not reflect the reality. Reality is garbage collecting, array AI, manual memory management, arenas are basically different kinds of memory management. They have their own pros and cons and different trades-off. And depending on what kind of application you're developing, you have to choose different kind of memory management. It's just like 98% of commodity applications are fine with garbage collector. That's why people perceive it as already solved problem, when in fact you just never worked in an area where it is not a solved problem. So yeah. Anyways, so this is, by the way, in D you can actually do pretty much all of the different memory management styles, right? You can do manual memory management, garbage collection, array AI, Arignos. Well, yeah, I mean, yeah. You can even have like a combined style of memory management. I think I already talked about that, but yeah. It's just you can choose whatever you see appropriate for any particular point of time. Okay, so what I need to do here, I need to continue. So include location. So I think it has to be a file location. File location. File location just indicates a file location is basically file path plus line. So it's usually used for reporting error messages and whatnot. All right, so include location. So saved. It's called prev. Include location. Include location. I hope the text is not too ppl. I hope it's not too ppl. So in this one is gonna be ppl. Saved in previous include location. Hello 0hpsb, welcome to the streams. Invalid initializer. Incompatible type, file location, and oh yeah, sure. File location. Read ppl. I think we have just ppl, do we not? I think we just have ppl. But ppl, I guess we removed it because it wasn't used that often as I don't know, anything else. So where is the file location? Oh, it's just called location. Okay. It's just called location, and holy shit, it works. Okay, so we fixed the assembly. Now we have a fail in other places where we use arena slurp file. Yes, our function that reads files is called arena slurp file because it slurps the file and lets you work with it. Does Chaturina still have the same bug here? It's not really specifically Chaturina bug. It was a bug on my setup. I think my cache got fucked up at the time, and I still haven't bothered to actually do anything about it. So I don't know, maybe it was a Chaturina bug that caused my cache to corrupt, and then later it got fixed, so the cache actually, yeah. Did we have, I think we had ppl, yeah. You never had that. Well, I mean, I also was developing Chaturina, right? So I was debugging, like stepping through the debugger, and I was actually intentionally crashing Chaturina in very interesting specific places. So maybe I accidentally crashed Chaturina like in the middle of transaction, whatever the fuck's supposed to happen. So I can see actually like my Chaturina cache being corrupted. Why am I the only one that remembers? I also remember that emote, come on. Like I also remember it, but I don't remember why I deleted it. Alright. Broke ppl. Yeah. The cache was so corrupted, it corrupted BTTV. Anyway, so what we're gonna do here is we have an expected output, right? So, and now we're gonna do expected output. And if this thing is less than 0, that means something bad has happened. So std error could not read file svfmt because of this thing. Okay. So, oh yeah, we have a sister version of this thing. We have a sister version, so I can just use that. Expected output file path, and the reason is str error null, right? And then we're gonna just do exit 1. There we go. So now we are capable of recovering from read file error. Okay, yeah, you can do that according to ISO-C. ISO-C. It sounds fun in Russian, that's why I'm laughing. All right. Is censored on default? Really? Is it censored on default Twitch chat? Are you? Oh, you just put kappa. Yeah. By the way, be careful with that word. That word is just like considered some sort of like age shaming or something. Like it's just fucking crazy. Twitch becoming more and more crazy recently. So I will probably have to rename my program. Ageist. Yeah, it's too ageist. It's an ageist slur. I suppose in that case as well as Z word, right? Well, I guess it kind of makes sense. It's like shaming people for something that they're not in control of, right? So because you're not particularly in control of your age, right? So yeah, it is what it is. Twitch banned the word. Yeah, I lost all hope for this platform. Yeah, it's just so weird. Like, all these words, I mean, they could be offensive, but in a very specific context. And Twitch even themselves said that the context matter, right? So there was like a talk by the director of Twitch or something that where he said that, yeah, so we look into the context and stuff like that. And the only reason why would I see people like them banning these words is because they just don't have time to look into the context. Well, yeah, it is banned only in aggressive context, but how do they judge it? Yeah, it's just... Anyways, just fuck at least one person to join Twitch. Nice one. Alright. Arena Slurp. Arena Slurp. So symbol table, and it's gonna be just a sim tab. I'm gonna just zero initialize this entire thing. Load symbol error. Don't banner me. Could not read file. I think it has to be svfmt, and the explanation is the following. So it's gonna be stt error. So svarg simtab file svarg. No, it's not svarg. It's actually str error. No error. No error. No, please no. Okay. Shit, seems to be working. Isn't that amazing? I think it's goddamn fucking amazing, mate. So now I need to actually properly report everything. So Basm translate source. Right, so it says could not read file blah blah blah. And in case of the include level being bigger than 0, we know that we are included. Right, so we have to do something like a file location fmt, and this is where we're gonna put our file location. And on top of that, we're gonna say flarg basm include location. Right, so essentially if you fail during an include, we're gonna report the include location properly, so you know where exactly you're trying to do a fucky wacky. That is a good compiler design. This is a good compiler error message. Hopefully, we'll see how it goes. It seems to be compiling so far. We can also run the tests just to see. Test pass. So the thing we want to do now, I'm gonna go to one of the examples, for example, and I'm trying to include something like fucky wacky .hasm, right? And it should fail because there is no such file, Right, there's no such file. Let's try to recompile this entire thing and see how how miserably it fails. Okay, so could not read file, fucky wacky hasm, no such file or directory, and look at that, I can click and I can jump exactly to the location where include has failed. It was not possible before because the function that we used for reading the file could not recover from the failure. Now we made it recover from the failure, now we can report includes properly. Okay, that's actually perfect. All right. Okay, so we solved the problem. We solved the issue. The issue was that include does not report location properly. Now it does report location properly. And another case to check is when you're trying to compile just non-existing file, right? Just a non-existing file. It's a build bin BASM, I think, and I can try to do something like this. Yeah, expected. Oh, you also have to provide output. Here's the output. Yeah, could not read file, blah blah. No such file or directory, and it doesn't report location. Same. God damn it. All of the words, I imagine a day when all of the words on Twitch are banned and all of the communication is done via Twitch moderation team approved emotes and only a particular combination of emotes. And then I realized, okay, it's kind of difficult to moderate particular combination of emotes because particular combination of Twitch moderation approved emotes can mean something offensive, so they will allow you to send only one emote at a time in slow mode chat, so you cannot form a particular offensive combinations of Twitch moderation team approved emotes. So this is how it's gonna be. Like if you extrapolate Twitch in 10 years, this is gonna be in 10 years. Let's make a cup of tea. Banned, insta banned. Bots. Bad. Burn. Alright. Bots. Ban and both. Permaban. Yeah, fresh bag of Earl Grey. Okay, good. So I kind of don't like how it doesn't wrap the file path in parentheses. I think I'm gonna quickly do that. BASM, where is it? bm.h, right? bm.h, and we're gonna just wrap all of that in quotes like this. Oh shit, I'm sorry. Test. Cool. Include. So let's try to do that. Okay, could not read file, no such file or directory. Okay, that's perfect. Really like how it actually, yeah, reports everything. That's pretty poog. So what was the issue? The issue is 143, and all right. There's no report location. Make include report location if the file does not exist. And let's push that right into the repo. Enough? I thought I made this typo. Okay. Fair enough. And let's close this issue. Let's go. Not you. Alrighty, so let's just wait for the continuous simulation and let's see what other issues we can work on. Semicolon in the end of the lerp BM example output. This could be interesting, right? So maybe I'm gonna dive into that. And also dump F64 doesn't support none and inf. So it could be interesting as well. Alright, but in the meantime, we're waiting for the compilation. Alright, while we're waiting for the compilation, I want to make a small break, boys and girls, like a couple of minutes. Yeah, just 2 minutes. Maybe even less, who knows. It's gonna be super quick. You won't even notice, seriously. Couple of minutes, yeah. Alright, let's make a small break. Let's make a small break and have fun. Yo, welcome back. Back. How everyone's doing? Still dead. Yeah, I'm sorry. Yeah, it's actually a pretty good album. I really like it. So, for those who doesn't know, we're listening to his old album, Achievement. You can actually find the link here. So, we're just listening to this album on repeat for 4 hours. Welcome to the Tsoding channel. Yes. Who needs any other music? Alright, so let's confirm the merge. And continue. Delete the branch. Mods. Merge pull request. Perma merge. Alright. Merger. Second degree merger. Sorry. Okay. I want to take a look at the semicolon of the lerp example. So it's a really interesting bug. That's basically what happens here. So we have a lerp example. Oh, by the way, my tea is ready. Just a second. I'm gonna pour hot water. Welcome back. Oh shit. Fuck. So, let's take a look at the example that causes the problem, right? So the example called lerp. It's ignored, by the way. It's ignored. Okay, so I'm gonna unignore it, right? And we might as well actually do the following thing. So I can just call no build record, and it will record the output of all of the tests and claim them as the expected. So after that I can go here and we have a lerp example, and this is the output of this entire thing. So it's supposed to actually output values, floating point values from 69 to 420, right, from 69 to 420, but for some reason it doesn't do that properly. It doesn't do that properly at all. Just remove the test and issue is fixed. Haha! Very funny. Very funny. Alright, so I tried to narrow down required conditions to reproduce. It seems that n has to be equal to 10, 0. B has to be equal to 0 in the end. The rest of the digits can be anything. Okay. For example, if A is bigger than... not quite sure what you're doing here. But I think the easiest way to understand what the hell is going on is to look in the debugger. We actually have our own debugger developed by Nico that we can use to debug our applications written in the Boson programming language. What you're doing here... Oh, I'm sorry. Anyway, so let's quickly do that. Let's take a look at the lerp example. Nico, who is Nico? Nico Sonic? You never heard of that very famous C developer? I would even say like a younger version of Dennis Clark. You know, the future Unix wizard. Nico. Damn it, come on, people, seriously. Alright. Nico. Alright. The tea is ready. Let's go to the example lerp. So this is how it's done, right? We have lerp. We literally have a function called lerp, which performs the linear interpolation. And I think I want to actually break somewhere around dump f64. Right, might as well actually put a debug in here. So yeah. So the reason why I want to break in here is because I'm gonna just break there and look at the stack and look at the values, right? And that way we will know what the value is going to be equal to reproduce the problem, if you know what I mean. Alrighty, so maybe we wanna, maybe we wanna rebuild everything. Let's just rebuild everything just in case. So then I'm gonna go to the build bin bdb. So this is the debugger. Okay, and we have to provide the executable. The executable is bin, not bin, but example lerp bm. We're gonna break on debug, right? And we're gonna run this entire thing. Okay. So let's take a look at the stack, and on the stack we have 69, right? We also have different like representations, but I'm gonna just continue and take a look at the stack one more time. So this is the next value. This is the next value. So we need to continue doing that until we encounter 400. 19, right? And we will be able to see the actual like bit representation of this value, and we'll be able to see what exactly is wrong there and what's causing all these problems. All right, continue, stack, continue, stack, continue, stack, continue, stack. So we have to do that like around, 10 times, right? Because we're interpolating in steps like of 10, I think. Stack. I think we're getting closer. Alright, so we've got this value. I think, so it is exactly 420. It is actually exactly 420, but if I continue, it prints it like that. Wow, that is very cool. So yeah, just literally try to print 420 and it won't be able to do that. So minority? Really? Are you sure about that? I'm sorry. Okay, so now we know at least it's like a hexadecimal representation, right? Hexadecimal representation. And we can try to reproduce that. Dump F64 bug is going to be bosom, and I'm going to include natives and natives hasm, and I think it has to be like examples of some sort. So this is going to be the main, and the entry point of the program is going to be main, and we're going to halt in here. So I'm going to just push 420 and just call print F64. Right, so, and let's see what exactly is going to be printed by such a simple program. Let's find out. So I'm going to do something like this. Hopefully it will rebuild everything. Okay, did it rebuild bug? Probably not. Wait a second, it didn't really rebuild the bug. So how do we actually decide whether to rebuild the file or not? So examples. Yeah, it should end with bosom, right? It should just end with bosom, but for some reason it didn't rebuild anything. Am I blind? Huh. Okay. Oh, okay. Now it rebuilt it. For some, maybe I just didn't save it. Okay, I just didn't save it. It has to be dump F64. Okay. Alright. So that actually compiled everything appropriately. To be fair, like these days, in no build, we don't really have to do this really weird thing. Right. So we can just do the following thing. If yeah, so this is the code from the very old days of no build. These days you can just do the following thing: if ends with, and you can do example dot bosom. If it ends with dot bosom, you can just skip everything here and just use this entire thing and just remove all of this shit. Like it's not needed anymore at all. So example base. An example base, if you think about it, right, example base is only used only once in here, so I might as well actually just inline it, no extension of example, and just call it BM, and just make it even simpler than that. So this simplification is insane. Look at that. So bosom, then you just call that, you remove extensions, add another extension, and everything works out really correctly. Very good. Alrighty. Okay, so, but that will require rebuilding the build tool as well. I didn't really want to record that, but I mean, yeah, that's cool. Okay, bug. Okay, and now we can take a look at the output of this thing. And printed everything correctly. Holy shit. It printed everything correctly. Huh. Okay, so that means it has a slightly different representation. what is the representation of that thing then? So we can look at it. We can look at it using the disassembly. I think disassembly will actually show all of the possible representations, if I remember correctly. If it doesn't, we'll have to fix disassembly. So bin. Oh my god, my brain doesn't work properly. Bin debusm, and it's gonna be build example dump f64 bin. Okay, so here is the entry. And here is the representation. Interesting. So it's pretty close. Alright, let's actually try to push that specific value here. Let's try to push this specific value. So, and in debug example, I'm gonna actually comment this thing out. And then I'm gonna push this thing. But I don't think we support hexadecimal literals. Do we support hexadecimal literals? It would be kind of cool if we supported them. I'm not gonna lie. Maybe we should add support for them. For hexadecimal. Alright, so let's try to do this thing. I'm gonna try to rebuild this entire stuff. IEEE bug confirmed. Do you think it's a IEEE? I'm not sure. It's definitely my bug. So this is a bug. Yeah. Oh shit. Oh, I mean, so it's actually like, you know, parsed it incorrectly completely. Dump f64. So let's try to add a support for hexadecimal literals. I think it would be useful in the future for everyone. Yeah, which is really weird. So it's basically, it even censors such words as, like, it censors the W word, because I'm really scared. Maybe if I say that word, it will censor me. I don't know. All right, so Normis is not sent. Well, bosom translate literal, right? So this is the thing that we need to do here. Okay, so we take a look at what this entire thing starts with, right? If it starts with, you know, prime, this is a character. If it starts with double quotation marks, it's a string literal. If it's something else, we do consider it. Oh shit, that's actually pretty cool. So we can use str2ull. And the question is, can I use the same to parse hexadecimal literals? Ribophobia. Yeah. All right, let's do some experiments. Let's do some experiments. We're gonna have main.c. We're gonna have main.c and str.l. Also, maybe include stdlib.h and a boom. I'm gonna remove this thing. It's gonna be just void. It's gonna be just void bm.h, and I'm gonna grab this thing. So this is a u64. So for that, I will need to I'll need to add this thing. It's gonna be uint64_t. It's gonna be x. Sister. Okay, so it's gonna be const char sister, and it's gonna have the value that we're trying to test, I guess. Maybe for now we can do something like ff, right? Let's try ff. So I don't quite remember str2ull. what kind of arguments does it take, like in terms of the const qualification? Okay, in terms of const qualification, this is really strange. Like, end pointer is supposed to be pointing to something within end pointer, and it actually accepts non-const qualified value, which means you can modify something that you cannot modify through that pointer. Fucking classic C library. Anyway, alright, so then I'm gonna say something like 16. And we can try to print some things, I suppose. C library, yeah, I'm just so tired ranting about it, like it's just whatever, I accept it. Oh, by the way, so recently, like, I still cannot wrap my head around it. So the exec syscall and actually their C wrappers, right? I'm talking about their C wrappers. So essentially, what you have to pass for the arguments there is this thing, which is effectively like a char star const star, right? So it has to be also an array, and this is such a weird choice of the const qualifiers. It's just like, first of all, it's really difficult to read, right? It's really difficult to read. You need to use cdecal to understand the shit, unless you've been programming in only C for the past 30 years and you understand the C gibberish perfectly. But if you don't understand C gibberish, you can try to do, like, put this into cdecal, and it will tell you that. Declare argv as a pointer to const pointer to char. Right, so this is really strange. Okay, so the problem with this kind of thing is that if you have an array of const chars, you won't be able to pass it through this pointer, because array of const chars does not allow you to modify characters within the strings. Alright, let me actually demonstrate you what I mean. So let's basically compile this entire thing and just make sure that it compiles. Yeah, I don't think we need to run it, we only need to compile it, just to see if everything's okay. Okay, look, so through that pointer, you cannot modify individual elements of that array. See? Each individual element of that array is not modifiable. But each individual character within that array is. That's what it means. That's literally what this kind of pointer means. And exec functions expect that from you. And because of that, you cannot pass something like that there. And I was trying to... I was trying to understand why. Why does this syscall, or at least wrapper for the syscall, needs to modify the arguments? For what kind of perverted reason it needs to modify them? And I couldn't understand. I even went to the extent of looking at the source code of Linux, okay? Linux syscall table. Yeah, let's just go there, I suppose. Right, so there is an exec syscall there, if the page loads up, and let's actually do like go to the source code of Linux, right? If I understand correctly, I might be actually wrong, maybe because I cannot read shit. But let's take a look at do exec entry point. Do exec VE. And in a syscall, both of these things are constant. So Linux kernel doesn't need to do that. It doesn't need to modify them. We can actually try to confirm that. Okay, so I'm gonna do it like this. I'm gonna remove all of this user qualifieds and whatnot. I don't think they're really needed. Right, so argv, I'm gonna replace this entire thing, and through whatever Linux kernel expects, you cannot do this shit, can you? Okay, so let's give it a try. So yeah, I should have actually done it. Yeah, you cannot. You can neither do that nor that. So Linux kernel, like, it doesn't want to do that. Like, it doesn't want to modify any of this shit. Like, it just doesn't care. But for some reason, C library that wraps around these C scrolls needs to modify them, or it doesn't need to modify them. Maybe it's just an overlook of the they overlooked in the design of the library, and they just left it like that for the reason of fuck you, I suppose. I don't know. Like, and this bothers me to such a fucking extent. And before it's only in glibc. Maybe. We can take a look at Musil, maybe, I don't know. It's just... And the reason why I'm even ranting about that is because this is exactly the problem, the problems that I have to deal with like in no build. Because in no build, I usually just manipulate arrays of const char stars, right? So, because that's what you do in C. And then I need to take these const char stars and pass them to exec VE, but I cannot do that. Because exec VE wants to modify particular strings, and I still don't understand why. I would understand if it needed to parse them, but you don't need to parse them. Like, why do you need to parse them? Just send them to the kernel. Like, what do you need it for? Anyway, I'm sorry. So probably to answer this question, maybe I need to even look into the source code of the libc library. Anyways, just wanted to let that out. Really apologize. Okay. Should have become JavaScript developer. Maybe in JavaScript you have more bullshit than in C. Which language has more bullshit, JavaScript or C? Nothing better than C. Yeah, and you know what's funny is that it's true. It's kind of true. Like, there's not that much of the alternative to C. Like, it's just you have to deal with the shit. C has more bullshit, yeah, probably. Well, JavaScript is so good. ARM has an instruction for it. Have you guys seen, like, who posted it recently in our Discord? Somebody, I think, I don't remember, was it Nico or somebody else, posted a link that in ARM you have an instruction with the name JavaScript in it, right? So it has a special instruction for, like, bit conversion of floating points in a style of JavaScript, and the instruction itself has a JavaScript in its name. An actual CPU instruction has a word JavaScript in the name. Holy shit. So we can even try to Google that. ARM.js float conversion instruction. I forgot how it's called. Yeah, this one. FJCVTZS. So it's a floating point JavaScript converted to signed fixed point rounding towards 0. So it's a special instruction for JavaScript, and well, I mean, there is no thing here, but yeah. No, they didn't embed the interpreter, they just have instruction. It is because JS uses double precision for the numbers, but if you want to perform operations with bits, the task is not trivial. So a specific instruction to convert JS double into integer makes the thing easier. This ARM link explains it very well. In order to add more information regarding fuzz comment, the difference between this and JavaScript version, both of them convert floating point to it, are that in case of overflow, the is that the JavaScript? The JavaScript one will be this value instead of overflowing. Furthermore, this can generate an exception in order to indicate how the conversion was. Yeah. Okay, cool. This name is x86-64ish, yeah. So, JavaScript infiltrated ARM architecture. It is what it is, and it isn't what it isn't. Haha, is it not? I think it is. The missile knows where it is, because it knows where it isn't. PRI U64, and let's actually put it like this. Someone just edited it during debugging and forgot to remove it. Yeah, classic. So we can also try the following thing. If sister, if so I forgot what end pointer should equal to if we succeed or not. I think How do I check that? I think you do end pointer minus sister, right? And then if it's not equal to strlen of sister, right? So you say that we couldn't parse it, right? And people say ARM is a risk of it, actually, yeah. Could not parse. Shit. Okay. Let's try to compile this thing. It's gonna be a out strlen. Okay. So let's include string.h and also int types, I think. Otherwise it won't work properly. And oh shit! It recognized the prefix in here. Oh shit, that's actually pretty good. What if I don't provide a prefix? It still managed to parse it. Huh. So it actually, if I do it like that, yeah, it couldn't parse shit. Okay, so alright, there we go. So I can actually leave the prefix in and just, you know, rely on this function. That's pretty cool. Alright, I can try to do something like this now. Can you parse this entire shit? Yeah. We might try to take a look at this thing. So I can put X in here for hexadecimal. And it looks pretty hexadecimal to me. Maybe not this. Are you going to support octal as well? I don't need octal right now. The only reason why I'm working on support for hexadecimal is because I need it right now. I really like this one, Prix 64. It's like the original name of Linux was actually Frix, right? So we need a Linux that also called Prix. Anyways. Prix 64 sounds like a pretty cool name for a Unix. Now, bm.h. So how are we gonna do all of this shit? So we're trying to parse it as so if we couldn't, all right. So we can do it like this. If SV count is greater or equal than 2 and SV data, I suppose 0 is equal 0 and SV data 1 equal x. This is how I check that it starts with 0x. I mean, okay. I could have just implemented something like SV has prefix SV 0x, right? Would it be better? Probably. Okay. I'm gonna implement this thing like that. Sure. But that means I have to implement this function, and I'm already shaving a pretty huge yuck. I forgot what was the original problem. The original problem, by the way, was actually fixing the incorrect printing in the dump F64, and goddamn yucks. Holy shit! Who cares? I mean, I care because at some point I may forget what I was doing, and I'm gonna be sad. But I'm always sad, so maybe it doesn't fucking matter. Anyway. So let's implement this function. SV has prefix. SV, here are all the functions. Right. So we're gonna return boolean and string view SV, string view prefix. So let's go to SVEQ. Where is this? Yeah, let's put it here. How would you implement such a function? If prefix count is greater or equal, actually greater than SV count. Well, first of all, it has to be less or equal than SV count, and then we can iterate through each individual character. Return random, yeah. Size t less than prefix count, and if prefix data I not equal prefix actually SV data I, we instantly return false. Otherwise we return true, but on top of that, otherwise in here we return false. Stern CMP null termination and stuff. I don't want to deal with that, and we have a string view. So we iterated through all of that was okay. Is there any easier way to do that? Hey, Hudson Plots, hello, welcome. How are you doing? Okay, so looks good. So if it has a prefix, we're gonna try to interpret this entire shite as, you know, hexadecimal literal. So it's gonna be result as U64 str2ull sister and pointer but 16, right? And if end pointer not sister, size t not equal to SV count, SV count, it will just have to return false. Otherwise, we set output to result. Okay, output to result. Okay, so that's the way to go. I see that Mr. Streamer merged my spammy PRs. Yes, I did. I actually merged them like 1 hour ago, roughly. Alright, so let's build the rest of this shite. And it doesn't compile, because why? SV from sister. This is how we do that. SV from sister. Can we get Hudson Plots bot banned if we report it enough? Well, that would be kind of a not a good move towards Hudson Plots, I think. Maybe. Mr. Plots. Can I actually merge these two branches together somehow? Maybe actually kind of cool. I don't know. Nah. Alright. So yes. So I'm gonna try to. So I already built everything, and I want to take a look at the debusm of this thing, and debusm actually did everything correctly. Yeah, debusm did everything correctly, and our printer, like printer from libc, actually, we're using here a libc printer, considered it 420, but if we execute this entire thing like this, build bin bme, right, I have to provide the input, and build example dump f64bm, and there you go, we found the bug. So here's the bug. Here is the bug, and the question is like, why does it do it like that? So that means at some point, at some point, something like this happens. Okay, I have an idea. We can actually narrow the bug even further, because the dump f64, basically uses dump u64 for the integer part and dump fraction. So we can take a look at how it calculates the fraction, right? And we can try to specifically print the fraction. So that could be actually very useful. Just take a look at what's the fraction though. All right. Let me see. So I'm gonna go into the examples and I'm gonna go into the natives and we're gonna go into dump f64. There you go. So there's something about negative or whatnot and so and this is where we do the print frac. Okay. So call frac, so you extract the fraction and then you print the fraction. So I would assume that there's something wrong with the fraction specifically. So I'm gonna put a debug in here. And we're gonna stop somewhere here. Alright, and let's try to rebuild everything. Hopefully it will fail. Yes, it failed. And yeah, I was expecting to fail because I wanted to test how it handles the label redefinition. So you see, debug is already defined bound, and first bound was made here. Right, so essentially it reminds me that I should probably remove it from here. Right, so that's actually pretty cool. And it works across the files, so it works across the files as well. So the debug label was actually defined in a completely different file and it reported it properly, so I managed to go there and fix the bug. So the error reporting is perfect. Love it. Yeah, worked so hard on it, oh my god. Alright. Okay, go. What do we have here? So I'm gonna go into the debugger, BDB, and let's go. I'm gonna break the debug and I'm gonna run this entire thing, and we are at so it already printed the whole part, which is great. Let's take a look at the stack. So on the stack we have 420. Okay, we have 420, and I'm gonna step. Oh shit! So frac is gonna be actually kind of. Yeah. So we need to. We definitely need to. I'm sorry. Shit. I sent. Did I set whole part instead of integer part? Yeah. I'm sorry. I'm Russian. So the thing is that like instead of saying integer part, we say whole part. Yeah, I cannot get over it, I'm sorry. I'm still thinking in Russian. I have a Russian brain. Yeah. So there's an integer part and there's a fractional part. Okay, same. So you also in German you call it whole part instead of integer part. So. Yeah. Okay. So I need to move the label slightly. It's the same word for us, yeah, I guess. Alright, so where is the debug? So I want to move the debug before print frac, just to see what it's gonna do there. But to be fair, frac, I think frac is actually a very small function. Yeah. Oh shit, and it does conversions and shit. You know what? Let's actually go through whole frac and see what it does. I think it's gonna be useful. So it's gonna be next. Okay. So swap one, next. That. So then we perform the conversion to integer. And that is for 20. Oh shit. That is so goddamn interesting. I found a bug. I actually found a bug. Well, I mean, bug was found by Kolumbetka, but I think I kind of understand it. So we end up with a fraction equal 1, but the premise of the print fraction function is that the fraction that you're trying to print has to be less than 1. It cannot be equal to 1. That is very goddamn interesting. So... And due to conversions and stuff, we end up with 419, and when you convert it to a fractional, so the fraction is basically 0.999999. Yeah, fake Portuguese. So I'm just thinking. I feel like if after extracting the fraction, the fraction is greater than, like, greater or equal than 1, we have to add it to the whole part. Integer part. Sorry. God damn it. I like whatever. The real question is 0.999. If 9 is period, then yes. So Numberphile actually made a video on that, where they explained that 0.9 period is equal to 1. And the reason is because of the decimal representation of the numbers. There is a flow in the decimal representation of the numbers which allows you to have several notations for the same numbers. So that basically was the explanation. I don't remember the details here, but it's a flow of the notation, essentially. It just allows you to write several numbers, the same numbers several ways. Everyone's an expert these days. Back in my days, people were arguing about this shit for days. Yeah, that's what you get in the era of the internet, right? So there's like an explanation of this kind of stuff. In case of the 0334, it's a flow in IEEE 754 specification. Not even a flow, but it's a quirk of the specification, rather, that you have to deal with. Anyway. Alright, so let me see. So maybe we can try to experiment with this kind of shit. I really want to try to experiment with this kind of shit. So let's go here. So here is our number. So it's gonna be uint64_t, and it's gonna be just x. My neighbors are cooking something very tasty. Holy shit. Anyways. Okay. So if I try to print this is around something like this, right? So this is like literally that. If you try to print it with a printf, I think what you'll get is 420. Cooking at night, well, yeah. Sometimes I cook at 3 a.m. or at 3, so yeah, at 3 of night. Yeah, I'm listening to the music. I actually can hear it through my lungs. Yes, I'm listening to music through my lungs. All right. So, and it's gonna be x and double. Okay, so let's try to print that. It's going to be gcc main.c, and I'm going to do it like that. And as you can see, it printed that fucking correctly, mate. How can I have different precisions though? I think it doesn't really matter that much. But yeah. I wonder what we can do now. And here's the thing. Now you can take this entire thing and you can try to convert it into uint64t. Right. You can convert it to uint64t, and look what's gonna happen. PRI U64. Okay. Yeah, this is so cool. I really like it. I found like a magical floating point number that fucks you in the ass if you're not careful enough. Yeah, that's so cool. So if you try to print it with printf, right? If you try to print with printf, it will tell you for 420. But if you convert it to integer, it's 419. It's the same fucking number, literally. So this is its bit representation. If you do this kind of shit, like, yeah, you get fucked in the ass if you're not careful. That's so cool. And we found this number completely accidentally. Holy shit. Wouldn't you get, if you increase precision? Probably. I'm not sure how to increase it though. Printf precision. MongoDB printf with specifier. Okay, so it's something like dot 2. Okay, so let's actually start with this thing. Okay, so that means if I try to like have 10, can I have 10 here? Okay, so I already have 10. What about 20? There we go. There we go. That's pretty cool. Wait a second. How many of these things we have here? So the precision is around 13 characters. Alright, so that's pretty cool. So basically you need to have a big enough precision. But it doesn't mean you don't have to handle that. But isn't the second line just casting double to int? Yes, it is just casting double to int, but that involves actually converting IEEE 754 representation to integer, and it truncates the fractional part. Right, and the fractional part, so the actual number here is 1999999999, and converting just basically truncates it like that. And that's why if you are not precise enough, you're gonna end up with 420. And if you convert it to integer, you're gonna end up with this thing. And the way we extract the fractional part is we take this value, we convert it to integer, then we convert it back to double, right? We convert it back to double, and we take the original value and we subtract that from the original value. So here I'll have to do something like 10lf, and we're gonna end up with 1. So this is the way we extract the fraction. So we could probably argue that this is not the correct way of extracting the fraction. But yeah, if the fraction ends up being something like this, wait a second. Yeah, I think it rounds up. What if I increase the precision of this? Aha. Okay. It's also not equal to 1 if you think about it. So that's the problem here. It's also not equal to 1. Alright. Anyway, so what if we try to increase the precision? I can set the precision to 20. I can set the precision to 20, and let me try to do no build record. Alright, test examples, bug, And yep, it worked correctly. And we can even take a look at the lerp. And lerp, well, lerp doesn't really look that good. So yeah. It's pretty close, I guess. It's pretty close. But why doesn't it work with smaller precision though? Why doesn't it work with a smaller? I probably could. Native Hasm, probably. What if I set it to 13? If I set it to 13 and lerp expected output revert. Well, that wasn't bad. But again, like with a smaller precision, why can't we handle that with a smaller precision, even though if it's like not what I think it is? Anyway, so I guess maybe it makes sense to make a cup of tea. Yeah, I think it makes sense to make a cup of tea. Alright. That was good, by the way, everyone. Portuguese is a more complex language than English. Interesting. Probably. It's actually not that difficult to find language that is more complex than English. Sorry, no offense. I think for a language that is lingua franca, English is quite good. I think lingua franca has to be simple, so it could be learned by a lot of different people. So just submitting another PR. I see. When you're giving us Russian lessons, I already gave so many Russian lessons. I don't know what you're talking about. If I didn't know computer history. Okay, like we have to be very careful with this word, by the way. With the Z word. Ageism. I want to learn Russian. Same. Russian sounds so cool. I want to learn that language. I wish I spoke Russian. Alrighty. So you created the pull request. Is that implementing print label for call? Okay, I'm gonna look at that a little bit later. Thank you for some plots. Right now, I'm like completely focused on the floating point issue. I need to understand what the hell is going on there. Alrighty. So that's very interesting. But increasing the precision is not the solution, right? Increasing the precision is not the solution. We need to understand why we're getting fucked in the ass. It sounds like during some operations there's like a really huge overflow. Natives. So when I print fraction, this is what I push here. Right, so this is what we push here, and at some particular point, the value after conversion here becomes too huge. It becomes bigger than 10. It becomes bigger than 10. And here is an interesting question. If you go to main.c and if you try to print something like, as a character, of course, as a character, 10 plus 0, what's gonna happen? Well, I think I'm doing something wrong here. I want to just do it like this, and just run this thing. Welp, here it is. Here it is. So that means here, at some point, if you look at some of these values, after doing float to integer conversion, the result becomes probably 1 or something. It becomes 10. Very strange. Truly strange. I don't think we kind of handle that. Alright, so I want to make a small break before I actually dive into this entire shit. So, break. Small break. 3 minutes. So it's gonna be 3 minutes, super quick. Right, nothing special. And yeah, you guys have fun. Yo, what's up? How can you hear me? I hope my microphone is still alive. What's up, Potato Passing By? Welcome to the stream. Welcome, welcome, welcome. Wow, 3 whole minutes break. Must have eaten something bad. Yes, a potato. Sorry. It's 3 minutes yet. Yeah, it's not 3 minutes yet. Yeah. Okay, I think the shit goes down somewhere here. You know why? Because we're trying to print the last character in here, and I actually cut some corners in the algorithm when I was implementing it here. So I think I kind of know where I did a fucky wacky, and maybe even an oopsie doopsie. Anyways, so let me go here and rebuild everything. Cool. Revert, here it is. So let's take a look at the original algorithm. Zozin, I think it was print F64. Did you shave again, or is it growing that slowly? What? What is growing? Anyway, so let me take a look at the original paper. Yeah. Here is the original Peppa, where we stole the algorithm for floating point printing. Can I invert the colors? I think I'm gonna just download that from the internet. Boom. PH potato, yes. And I'm gonna do a mu PDF. And in mu PDF, for those who doesn't know, you can press I, and it inverts the colors. So, and now it's pleasant on your eyes and shit. All right, let's take a look. Yeah, here's the algorithm. Here is the algorithm. Yeah, basically I cut corners on this particular condition. I think I implemented only like one branch. Yeah, and what's interesting is that you can see that these conditions are overlapping, which is really interesting. So first you need to check whether r is less or equal than half, and in that case you don't have to you know, do this thing. And then you need to check again if r is greater or equal than half, and then you have to do +1. I wonder why they're overlapping. Does it have anything to do with the quirks of IEEE 754? It could be, but I actually thought that it's kind of dumb, so I just didn't do that. So maybe that's exactly what I need to do. It's really strange, very strange. Alrighty, so let me see if I can do that. So I want to actually open it with mu PDF, like with detaching things. Current91 subscribed for 2 months with tier 1 subscription. Thank you for you know, being a 2-time champion on the channel, and welcome to our epic IEEE 754 club. Welcome. We have a carrot and potato. Yes. Veggie gang. Okay. So yeah, let me try to see if we can do something about this thing. Majingi. Maybe they even explain why it is like that. Natives. So where is the condition? It's a print frag. Veggie gang. Okay. All right. So duplicate 2, push a half, and essentially, if it's less or equal. You skip the increment. Less or equal. Less or equal. That's very strange. So less or equal should jump over it. But if it's not, we want to check that one more time, I suppose. And why do I duplicate 2? Well, I mean, so you duplicate this thing twice. This doesn't make any sense. Like you dupe 2. Right. This is the top 0, 1, 2, and here's your value x here. So essentially you duplicate 2 and you put x on top of it, and then you push 0, 5, and when you do left you either get true or false. Right, and then this thing doesn't particularly make any sense unless oh yeah, because I'm doing F instead. Okay, I see. So that means here, somewhere here, within this thing, I need to do something like this. Right, I need to duplicate it one more time. Duplicate 2, push, and I want to do Jeff, and then not Jeff, if I remember correctly. But in that case, maybe I have to do not B. I don't quite remember which one should I do. Right, so let me take a look at the BM in here. Not B. Not B. Alright. And when I do not B, I just invert this thing in the sense of a beat. But do I have like not? Yeah, I do have a not, which is a logical not. Okay, I can just put not. It's not Jeff, it's Gef. Yeah, sure. So it's just gonna be not. But if it's not this thing, I still skip this entire increment, which doesn't make much sense, as well as the whole condition here anyway, but it could be because of the floating point bullshit. So dupe 2, push 0, 5, and then Jeff, and then not Jeff, and if it's not Jeff, you still skip +1. Well, I mean, we do have a gay instruction, but I mean, we're doing floating point right now, so we're gonna use gay instruction when we're doing integers, so don't worry about it. Alright. Okay. Cup of pride instruction, exactly. So it's kind of interesting. So if it's greater, we still want to do that. So we double check this additional condition. It's kind of a strange thing to do here, but okay, let's give it a try. Let's actually try to record all of this and see if it fixes anything. And it didn't fix anything. Yay! I'm so happy. It didn't fix shit. Epic. Absolutely fucking epic. Gay instructions. If it's less or equal. Less or equal. I still not fully understand at which point this kind of shit happens. Alright, so let's remove this stuff and go into the debugger, and I'm gonna take a look at the internals of this thing. I'm gonna remove this thing for now, and also this thing for now. Where's the debug? Okay, here it is, and I'm gonna remove it here. Print frac, it's gonna be here. Let's put the debug here. So we're gonna duplicate this value, and we're gonna just take a look at that value. Cool. And yeah, we rebuild everything. I'm gonna break on debug. If it's non-binary, qubit is binary anyway. It's just it's in two states simultaneously, right? So let's run it. Yeah. Okay. So let's take a look at the state stack. Cubic bits, yes. All right. So yeah, this is what we have on the top here. But this value, with enough precision, I think. LGBT qubits, yes. It's not necessarily 1, and that's the problem here. It is not necessarily 1. So, yeah, and on the next iteration here, we have this 1, which is not necessarily 1. And we compare it to, yeah, let's make another step, to half. Right, this thing is greater. It's greater than half, for sure. So we're checking specifically for less. If it's less or equal, we do... And it ends up being 10. But wait a second. If your value, it was greater, it was greater than half, so we just added +1 to that value. We're actually comparing R. Alright, I'm gonna go boil up some water. I'm gonna go boil up some water and then I'm gonna be back. It's a really strange problem, and apparently people don't like me actually thinking about this problem. It makes the stream boring. Sorry. Mm-hmm. Mm. It's already 10, isn't it? It's already 10. Or is it not? So it's not in floating integer conversion. It's already 10. It's already 10. Okay. So let me see. All right. So that's pretty cool. This one is not particularly, but maybe it could be useful. I always regret when I remove some code, even though I think it's not needed anymore. Yeah, so this is already 10, so there's nothing to do. So it has nothing to do already at this point. It's already broken. It's already broken at this particular point. So what if we take a look at this particular point then? This is not what I wanted to rerun. Let's do a record one more time. And let's break debug and run, like, take a look at the stack. Well, it is... Huh. Yes. And this is not 1. This is 100% not 1. If you take a look at this value, this is 100% not 1. So if you give it like a huge precision, it's not going to be 1. Yeah, that's what it is. But since it's greater than a half, right, according to this algorithm, since it's greater than a half, it should be incremented. It should be incremented, but why does it have to be incremented? So it worked, the conversion and truncation worked correctly, right? Conversion and truncation worked correctly. I didn't see any problems. So this is a fraction, right? This is a fraction, and at some point we just have to stop. But I guess the problem is we ended up with this thing. I feel like I'm missing some particularly important clue of this algorithm. And I don't understand which clue I'm missing, and it feels like the entire algorithm should also extend to the whole part. Right, it should extend to the whole part, but maybe not. Maybe I need to find some implementations of a finite precision fixed point fraction printout. Okay, let's actually Google them up. Yeah, because maybe my implementation is actually incorrect. This is just a pseudocode, right? And also some of the information is outside of the pseudocode, so I might be missing something. All right. Finite precision fixed point fraction printout. The reason why I'm doing that is just because I want to copy paste that to the Google and just find examples of this implementation. Well, I mean, I already found that. I wish there was like a good implementation that I can use as a reference, right? Fixed points, okay. Cool, thank you. Is there implementation that is working and we can explore? Because there may be some particular things that I'm missing. Probably not, because all of these people are mathematicians instead of being programmers, so they never provide any source code. Right, because source code, who needs source code, am I right? Implementation. Not a single implementation. This is so really strange. Only papers, only words. Where's the code? Where's the actual working code? Goddamn mathematicians. Just wasting everyone's time as usual. Okay, so maybe we can read something here. Maybe there's some useful information that I'm missing. Okay. I'm so demotivated. So I guess, according to my observations in the debug, we should have not received 9. Okay, so if the final result ends up being being 10, we should add that one, that additional one, to the whole, to the integer part. We need to add it back to the integer part. That sounds like a pretty good solution, I suppose, but that means we'll have to restructure the way we implement all of that. Right, so first we'll have to print out the fraction somewhere and understand that it needs to additional carry out. Right, then add that to the integer part, only then print out integer part, and then print out the fractional part. So this kind of stuff makes the algorithm even more complicated than it is right now, because I have to retain this information. Alright, we can try to do that workaround, because that's probably exactly what we need to do. But before I can actually do that, I think I want to implement that algorithm in C, right, this idea in C, and then we can try to, carry it over to Boson, because, it's kind of difficult to modify Boson in that sense. So yeah. Oh boy. So we'll say when we're printing out the integers in a fraction, right, you have to be doing that in a particular buffer, right, you're doing that in a particular buffer. Oh, ooh, it's just very complicated if you think about that. It's just very complicated. So that means I have to change completely the paradigm in which I print the numbers. So the paradigm has to be completely different. Oh, that may require re-implementing like the whole printer now. Oh shit, oh my god, this will require implementing the whole printer. Ooh, we're up for adventure, boys and girls. We're really up to adventure. Not like anyone cares. I do understand that nobody gives a shit about that. Yeah. At least maybe now, once I know what needs to be done, it's just maybe gonna be more interesting to watch. Ooh. Holy shit. But what if this kind of shit happens in... What if this kind of shit happens in the middle of the computations? Can it happen in the middle of the computations? Do we really do anything about that in the middle of the computations? In the middle of the computations, can it happen in the middle of computations? Or do we have some special code that prevents that from happening in the middle computations? And if we have some special code that prevents it happening from the middle computations, maybe we can just put it here as well, and maybe that will save it. Well, you still need to increment the integer part. You still need to increment the integer part. Alright, so let's actually try to implement that in C and see if this kind of problem appears in the C version of the algorithm. Interesting. I feel like we're gonna have a lot of bugs with the floating point printer. But Zosin, just use the C library. It's that easy. Why are you reinventing the wheel? Yes. Cerimon, hello, welcome to this stream. Welcome, how are you doing? Alrighty. So what I need to implement here, we're gonna probably implement only print frac. Let's implement only print frac. So it's gonna be just double X, and let's go ahead and implement this algorithm one more time. Okay, so F, if I understand correctly, is the input, right? It is an input, so maybe that's why I'm gonna call it F like this. Oh, just give me a second. I need to just bring all my motivation back. I'm really sorry. It's just sometimes it's difficult to stay motivated. Especially when you have to deal with a constant stream of Dan Kruger. Alright, so yeah, let's go ahead and do that. So we're gonna have R. So we also need to have M, and N, if I remember correctly, is the precision, right? So is the precision. So precision. So it's gonna be around 10. And I forgot what we make B in here. So B is the radix, right? So I think, yeah, this is how we actually start here. Double M. B is 10, so that's what we do here. And then, well, it has to be, if we have to be like iterated 10 times, yeah, it has to be then 1. So and if I want to do something like size T, 0 less than precision, excuse me. And I want to actually not really multiply, but yeah, actually multiply by 1. Right, and after that I'm gonna do divide by 2. I'm dividing this stuff by 2. Right, okay, so then I'm organizing the loop. Right. So then we need to have U that survives the rest of this stuff, right? So R multiplied by 10. So maybe I'm gonna actually define B somewhere. Maybe not. Then R becomes R multiplied by 10. And I keep forgetting this thing. What is this thing? I think it's a fraction part of x. Okay, so we take a fractional part of that x. So we multiply it by 10. Oh, by the way, if it's implemented in C, maybe I will be able to step debug the entire thing and see if it's at which point it it starts failing. Okay, so we're gonna have a fractional part. Sibane, thank you so much for 2 months of a tier 1 subscription. Thank you so much for 2 months of tier 1 subscription, and welcome to our epic Dank Club. How about that? How about that? Alrighty, so yeah, let's actually do this thing. Frac, you take the value, and essentially what we do here, we truncate this entire thing. I converted to int, actually to int 64 underscore t. Okay, so we're gonna assert a pretty interesting thing here, that this thing is greater or equal than 0, so that's quite important. So that's the assertion I'm making it. Don't really care for the rest of the cases. So then I need to subtract double u int 64x like this, and then we're gonna just return this entire thing here. Yeah, so this is the fraction, and alrighty, so then it works like this. Then we do m, where m is multiplied by b, and if r, so basically we're checking whether the r is within this range. Hello John Pumthong, welcome to the stream. Let me guess, how to become a better programmer, right? Anyways, so there we go. Hello Fruitful, welcome. How are you doing? So if we are outside of that range, right? If we are outside of that range, we're gonna be breaking out of this shit. Right. What's the PDF name? I can give you a direct link if you want. So it's this one. There we go. It's just a paper about printing floating points. So yeah. Hello, Dr. Poopy. Welcome to the stream. How are you doing? So, and after that, we need to print u, right? So u is a float. So I'm going to be converting it to. I might as well just convert it to a char, I think. That's very specific. Yes, it is pretty specific, not gonna lie. So I mean, it's just a paper, scientific paper on how to print things. All right. So and then I can just try to add 0, and I'm gonna just print this entire thing. Can I do put C? I think I can do put C. All right. So after we break, we have these kind of conditions, right? If r is less or equal than half, right, we have to print y as it is, right? Otherwise, if r is greater or equal than 5 for some reason, we have to do +1 in here. Do +1. And then, so there is a situation when it doesn't print anything. Huh, that's very strange. Okay. Okay. So here's the implementation. Let's see if it's actually doing it. It's almost like getting fucked by floating point numbers was not enough. Now I need to get fucked by Twitch. Thank you so much. Holy shit, that's a very bad day today. Okay. So let's try to actually run this thing. So uint, oh yeah, uint 64t. Okay. 10, sure. Anything else? Put C. So put C also accepts std out. It accepts it as a second argument, sure. Std out. I wonder how many people we actually lost because of that F. Probably a lot. Probably like a third of the people just nope. Fuck that. Don't want to watch that anymore. Okay, so let me try something. So here is our buggy value. Here is our buggy value. So I take a pointer to x and I reinterpret it as a pointer to double, right? And then I dereference that pointer and I also take a fraction out of that value, right? I'm essentially reinterpreting this value as a fraction. And might as well actually try to print this fraction before trying to do anything, just to see how it's gonna go. Just to see how it's gonna go. Okay, show me what you've got. It basically interprets this fraction as 1, but it's not really 1, right? If you give it precision, like a high enough precision, it will tell you that it's actually 99999, and it goes to bullshit. Okay, so if I try to print that thing, it's not gonna print correctly. It will print you this. So we can even reproduce that bug in the in a C version. It feels like it's a legit bug of a fucking paper. It just doesn't handle that situation. Or maybe I'm doing something wrong. I don't know what exactly is going on here, but yeah. Also, maybe it would be better to use multiplication here. So I think that paper, like we're implementing an algorithm that is deemed by the paper as not really important one, right? So really like something that you probably shouldn't use because it's slow and it's not like cool enough. Yeah, you know, stuff like that. And nobody gives a shit that it's actually the simplest algorithm. Right? So it's a very simple algorithm. And I like simple algorithms. And what's funny is that if you give it more precision... Ah, I see. So again, if you actually give it like 20, it will actually go further and give you this entire thing here. That is because it can go really, really far away, and once you've got this precision, All right, so how are we gonna implement the carry over, right? How are we gonna implement the carry over? I'm thinking we can implement it. We could have a separate function that tells us you have a carryover of some sort, right? And by the way, is there any guarantee that this kind of shit will become greater than 1? Is there any sort of kind of guarantee? Also, I want to extract this to a separate function. So in C you have a poll, right? In C you have a poll. Sure. Google has all of my data. Why can't it guess like what I need just by a single word? Come on. For fuck's sake. CPP reference. Okay, so let me take a look. Oh, man. So base and exponent, and yeah, so maybe I'm gonna do it like that. So this is gonna be a poll 10 to the power of minus precision, right? Which I can then multiply by half. Alright, so this is what I want to have here, so it's easier for me to do this kind of things. Now I also want to import math. Cool, it works. So, and if I try to do this kind of thing, okay, it doesn't. So here's an idea. Here's an idea. What if we take this thing, right? We take this thing as a separate function. So, and this is a precision. This is our precision. And then we check. Well, we can do something like this. It could be D. That the fraction of this fraction subtracted from 1 is greater than this precision. You know what I mean here? You know what I mean? So, if this condition is true, if this condition is true, we can straight up truncate the fractional part and add 1 to the original one. So essentially the difference between 1 and this fraction is so small, it's smaller than precision. It's smaller than our precision. We can even probably check that. It's smaller than our precision. Yes, it is smaller than our precision. So, is it really? What if I put like a 10 in here? Yeah. Yeah, perfect. So the difference between 1 and fractional part is smaller than our precision, so you can just don't print fractional part. You can just fucking ignore that. So yeah, and it's actually pretty easy check that we can employ in our standard library. I think it's gonna be cool. So, and the question is like, can something like that happen in between the numbers? No, it cannot, because we always, we have r, we make sure that r is less than 1, and multiplied it by 10 doesn't make it greater than 10. So that's okay. Hello RKMC, welcome to the stream. So that's okay, that's something we can do. That's definitely something we can do. All right. So let me see how we can implement all of this. So we can also have print integer, which accepts uint64t, and let's just quickly implement that. Printing integer is a little more complicated, right? Because you have to reverse shit and whatnot. But yeah, to be fair, like, we're not caring about print int. We don't have a bug in print int. So that means we can just do it like that. It's gonna be pre i64, because u64, and I think maybe, is it pre s64? I don't remember. It's x, and there is also I. Yeah, it's I. Okay, cool. I, and then we just put x in here. All right. So let me see. Void print f64. So I think I'm understanding what's going on. That's actually pretty cool. I want to assert I just don't care about negative part, because it's actually pretty easy to implement, right? Negative part. So we're gonna focus on the positive part, right? So it's gonna be greater or equal than 0, or whatever. All right. So, and the thing we need to check here. So I'm gonna just do this thing, where I take the x, and here's the x minus fractional part of x, and all of that converted to integer, I suppose. Converted to integer, and then print frac. I just do frac x, and also between all of these things we can print a dot, and then we can do print f, a new line. There we go. So cool, very cool. Now let me try to do something here. Print f64 is going to be 1, 2, 3, 4, 5, 6, 7, and let's see what's going to happen. Is it going to work appropriately? Yes, it did work perfectly. Nice. And now let's employ the idea, right? So I take the fractional part of x, and I also take the precision. Precision is essentially pole 10 to the power of minus precision, to the minus precision, and we're also taking a fractional part of it and subtracting it from 1, right? And if fractional thing here is less than our precision, what we're going to be doing, we're going to be only printing the integer part plus 1. The integer part plus 1. Otherwise, and we can actually, like, after that do something like print f 0 or whatnot, whatever, it doesn't really matter. Right, and in here we're going to do this thing, so it's going to be that, then dot, and then fractional part, and then a new line. All right, so we're going to remove this handler, and we're going to try to print this specific value in here, right? The very specific value that fucks you in the ass every time you try to do that. So it's going to be x double pointer, and then I dereference it and I reinterpret it as a pointer, and that should cause the well-known bug There we go. So here is the well-known bug. But now we employ our check, right? And it works. Yes. Nice. Pretty cool. We fixed the bug. So, and we know exactly why it happens, right? And we know exactly how to fix it. And I didn't expect that we'll be able to do that actually, but we now need to move that back to the bosom. And the cool part about this is that you can put it on top of the existing implementation. All right. But here is an interesting thing. So does it have to be equal as well? Does it have to be equal? All right, so let me try to explore some of the ideas. Essentially, so this is a 10. If you increase the precision, it still exists. Okay, and it stops existing like around 13. Yeah, around 13, it actually, you know, starts working. It actually starts working, and I wonder if now I employ this thingy here, what is it gonna do? Okay, so maybe it has to be equal. Nah. Should it be equal? So what does it mean? I think it could be equal actually. Yeah, I think it makes sense to keep it equal. What do you guys think? So you have this fraction, and so if it's equal, that means there's at least like one thingy there. There's at least one thingy there. But at some point you can also do it like that, and it will keep increasing the precision. I'm just not sure if it... Does anyone have any ideas? To be fair, we're using M. We keep in the original algorithm. So this is the precision, right? This is the precision, and in the original algorithm, we keep... Oh, this kind of thing even appears in the original algorithm. Holy shit! Okay, that's really funny. Okay, so that means maybe I want to actually keep it equal. I didn't notice how, like, yeah, this idea just appears because M is equal to the power of the precision. Yes, it is equal to that. Holy shit. I forgot 0.5. You think 0.5 is important? Why do you think 0.5 is important? Okay, maybe it is. Let's actually try that. Rounding, yeah. 0.5. Okay. If it's equal, doesn't really make any sort of change. All right. So. And if we go to 12, all right, so 13. All right, so I think I'm okay with this entire stuff. Now we need to move all of that to bosom somehow. We need to move all that to bosom somehow. The coolest thing is that I don't have to touch print frac implementation. It's just can be solved on top of print frac inside of like print f64. This makes me happy actually. This makes me very happy. So yeah, well, right now we just have this thing, and I just need to wrap it into additional condition and just, you know, forget about it. All right. We can even try to whatever. Yeah. Cool. You know what? Maybe it makes sense to actually document that somewhere, because I'm pretty sure, like, even my implementation in assembly has the same flaw, right? So we can even try to test it, because my original implementation in assembly like follows the same idea, right? It follows the same idea, and print F64, right? So here in assembly, what we're trying to print here, we're trying to print a value, right? But what if I try to print that magical value, that fox in or in the S, right? So what's gonna happen? Right, let's actually run build sh, and it created the thing. Huh. Why did it work? How did it work? That's really strange. Yeah, 19 is wrong, but why didn't it actually print the colon? This is x86-64 assembly. Or NASM, I mean, yeah. Sure. Okay, it's still wrong. That's very strange. So maybe we're doing something weird in assembly? Probably. Yeah, in x86-64 you have these kind of instructions. Anyways, so let's go and try to port this kind of stuff to Bosom. But maybe I want to make a small break, actually. Let's actually make a small break before I continue doing this kind of stuff. Around 3 minutes, I think, should be alright. And yes. Alright, let's make a small break, and you guys have fun. Phew. Okay. Let's take a look. So main.c. Maybe we don't even need printing here, right? So the thing I want to do, I still want to actually commit it to print F64 and also have some additional idea. Yeah, I'm gonna just commit it as it is, and then I'm gonna clean up the repo, because I think this is a kind of a useful information. All right. Main.c. Okay. So precision bug. Right. Here is a precision bug, and this is a fix for the precision bug. Hopefully, add the example. Add example of the precision bug. The bug was discovered by Columb in and let me find this thing. Right, so I'm gonna push that right into the repo. For those who are curious, so we have a special repo where we just experiment with floating point numbers printing. What's up, Jiang? Hello, how are you doing? Welcome to the stream. We're fixing bugs in floating point printing. I don't know if you saw that bug, but we have a really strange bug in here. Right. So sometimes instead of like printing 0, it actually prints like colon. So it's really painful. So, and the problem is caused by this value actually, specifically. It's a very interesting value that we accidentally get. Right, so if you try to print it like this, so first you have to reinterpret it as a double, right? And let's do that. Yeah. The printf will tell you that it's 420, right? Unless you give it precision of 20, and that actually screws up our printer like a lot, because if this like small part less than the precision of our printer, so the number here overflows. So basically here you would have 9, actually. Yeah, essentially you will have 9, so it will overflow, and the next character after 0 is going to be colon. Right, so, yeah. Essentially the idea is that before printing anything at all, we compare the fractional part with the, like, subtracted from 1 with the precision, and if it's less than precision, we don't even try to print the fraction, we just, you know, round the whole part. And that's it. I guess the algorithm I stole was better than the one you stole. Yeah, probably. Because I actually stole the worst algorithm from the paper. And the reason why I stole it is because it was the simplest to implement. Yeah. But yeah, what's funny is that maybe I didn't read the algorithm carefully. Maybe they explain that later, but if you just blindly implement that algorithm, it will have that bug. So yeah, so like really, it will have that bug, and this is one of the fixes. So I don't know. It is what it is. All right, but yeah. Essentially, we fixed it. It actually was relatively easy to fix. You just compare the 1 minus fractional part with the precision. If it's less the precision, don't bother printing the fraction at all. Just round up to the whole part. So, by the way, Jiang, you probably have like a floating precision, right? Do you have a fixed precision? We have a fixed precision. Right, so it's kind of controlled by the hard-coded value. Didn't print anything. Oh yeah, shit. Okay, so yeah, we get something like this from it. Right, but if the precision is under 13, it's gonna be for 20. Something like this. Alright. No, it's pretty cool that we managed to find the problem and fixed it. Now, as I mentioned, we need to port that to the button. So there we go. Interesting bug, to be honest. Yeah. So yeah, same. Like that's why I'm trying to like. And to be fair, choosing the dumbest algorithm was very beneficial, even if the dumbest algorithm had a bug, because since the algorithm is dumb, I, with my dumb brain, was able to understand it and fix the bug. So yeah. That was actually paid off. Choosing the dumbest algorithm actually paid off, even though it was buggy, because then you have enough brain power to actually fix it. It's pretty cool. Yeah. All according to Keycard. Yeah. Classic. Got him! Alright. I'm gonna leave it like that, actually. It's fucking hilarious. Alright. So let's go back to the examples and maybe we'll be able to fix all that shite. So in the print frac, so we do computations, do we? Oh, we have B. Oh shit. Yes, collide. So we already have this shit extracted as a separate function. Imagine the random dev being confusable for a good minute, yes. Alright, so it's 1 to the power of minus n, and yes, that's what we do here. Ooh, Freefu, you haven't been on our stream for quite some time. So here's a dump F64, and essentially, what do we do here? Yeah, so let's actually go through all of that. Right, let's go through all of that. So you have a value, and then you have a return address, and by the swap, we just swap them around. Okay, cool. So we duplicate that, and then we push -0, right, and then we do end B. Right, then we do end B. I suppose end is this, right, it's end B, and then it's not, and this is how we check whether it's negative or not. Okay, that makes sense. Yeah, this one is actually pretty straightforward, right, so just, it negates the value if it's negative or not. So first of all, it tries to do that, so after this thing, we're gonna have like a regional X, so. Alright, so then we duplicate the X, and then we convert it to integer, right? Then we convert it to integer, and then we print positive. So this is around where we have to start checking for this shit, right? We need to start checking for this shit. I think I need to push the precision. So let me actually put debug here. Do we have a debug anywhere else? Okay, so I don't care about this debug. The second debug is here. So where is the precision? So this is a frac precision. Okay, so we put a frac precision in here. There we go. What do we call B? So then we call B, and then we just do all of this shit in here that we can just do it like that. So we call B, that gives us n to the power, actually b to the power of minus n, right? Then we push 2, and we divide everything by 2, so this is basically what we get, right? So this is basically what we get. After this, and essentially, we need to take the fractional part of this entire shit, right? We need to take the fractional part of this to perform the proper comparison. Where is this? Okay, so I suppose I need to duplicate 1. After duplicating 1, I'm gonna have this here. Do I have a fraction? Fraction function? Yes, I do. Cool. So I duplicate that, then I do call frac, so that gives me a frac. Cool. Then I need to push 1. Right, that gives me 1. But if I do minus right now, it's not gonna work properly. If I do minus f, it's gonna subtract this thing like this, which is not what we want. Right, which means that probably we have to do that slightly differently. So what I'm thinking is that, yeah, let's put it like this. So I need to remove this shit. Okay, doesn't give me enough room. So I actually push 1 first. Then I duplicate 0, 1, 2, IO2, so that gives me x. Then I call the fraction of this thing, that gives me a fraction. Right, and then if I do minus f, I essentially subtract this thing from the fraction. Perfect. Perfect, so this is what we've got. We've got this entire thing, and now we need to compare it with this thing, right? So, yeah, so this thing was computed by this entire stuff, and this thing was computed by this entire stuff. Perfect. That is cool. Now, yeah, frac. I wonder if the compiler will tell me that. I think it would, maybe not. No. I missed the flow. Oh, all right. Okay, so we can only compare this thing like this. We can only compare it like this, and that means we have to use greater or equal. Do we have to divide it by 2? I forgot to divide it by 2. Shit. Oh, fuck. I forgot to divide precision by 2, didn't I? No, I didn't. Oh, okay. Yes, you see, I missed the flow. It doesn't matter. If the compiler would tell me, it doesn't matter. Okay. All right. So the power, greater or equal. Cool. All right. So greater or equal. So that means it's Jeff. So this is the result of Jeff. Cool. Result of Jeff. So I suppose if this thing is true, we just wanna skip to the other part. So, and Maybe we can do a not on it. We can try to do not on it. So it's gonna be... well, if we're gonna do not, it's essentially less than, so we can do LTF. Right, it's gonna be this. If this thing is less, it's the same as negated, right? So we need to skip this entire part, right? So here we do print positive, right? But in fact we don't need to do that. Okay. We can do something like jump if skip dump f64 skip frac. Right. And how much of the frac we're skipping? So printing the positive, then we print this thing, print fraction, then print a new line. Okay, so this is a new line, right? So this is a and in here oh, it's really complicated. It's a very complicated logic. I really hate it. So this is a new line, right? Skip negative. So this is how we skip it. So we check this entire thing. So in here, what essentially we're doing, we're just printing like the usual thing, and basically we have if else with two branches. Right, so if else with two branches, and I just need to properly do all of that. So maybe I'm gonna just duplicate this entire thing and think about like the second branch in here. So this is the second branch. Alright, so by LTF or whatever, it was consumed, but I really don't want to remove that, so I'm gonna just put it like that. Right, so, and in here, right, we have X, so it's gonna be push 1. Right, you do push 1. Actually, you can straight up do a frac of it, I think. So we can do call frac, so that gives you a frac. Then you push 1, and then you do plus I. Do you do plus I or plus U? No, we don't have plus U, so that means it's gonna be like this. Right, so we do plus U, and once you have a plus U, you can try to print the positive, right? So you print in the positive. Well, yeah. So fraction, well, no, you don't need a fraction. You need a truncation. Yeah, so we don't, oh my god, I'm confusing everything. I'm confusing everything back to the original thing. Back to the original thing. Okay, so what I'm doing here is I'm calling float to I, right? Emacs, stop. Float to I. This is what I have here. Then I push 1, it's going to be 1, and then I do plus I, which adds that 1 here. So we have this thing, and then I can try to print positive. I'm going to call print positive. Right, that gives me print positive, right? Too much, not enough screen. So this is how you print the positive. Then we can print a dot. Right, so we print the dot. And after that we can also print a 0. So that should be enough, I think. So here it is. It's kind of dumb, but I mean, yeah. So, all right, let's go back to this thing. So if it's less, so here's this branch. So we have a no frac, right? No dump F64, no frac, right? And when you and also you have no frac end. You have a no frac end, which you're probably also gonna put it here, right? So Emacs, stop! I didn't want to do that. Okay. So, and in here, you want to do the following thing. You want to actually jump unconditionally to no frac end, right? Because you want to bypass the else branch. So this is the else branch, or whatever the fuck it is, doesn't matter. Alright, so, and here is that. So if this thing is less, what exactly is less? If the precision is less than that value, you go to the dump F64 skip frac. Where is it? I called it no frac. Yeah, let's call it no frac, whatever. No frac. So, which just prints all of that without a fraction, right? If this condition okay, jump if holy shit, this is so confusing. Okay. So this is the check. So if it's less, then we do to no frac. If it's not, we're gonna go here and actually request. The two like branches if is just fucking impossible, like in this thing. Well, I mean, it's not impossible. It's just like I'm really tired and I don't have a prepared mental model that I can put like use off of shelf. Right, so I need to develop it myself, and people are fucking leaving. It's not interesting to watch. All right, so I think I managed to do this. It's really hard. It's really like whatever. It doesn't matter. Okay, seems to be working. So let's do a record. Let's do a record. Is the record examples? Didn't it? It didn't work. It didn't work. Why is it work? Did it recompile everything? I'm not sure if it compiled everything. Wait. Logic is broken. LTF. Where is it? Okay. Holy shit, that was not worth it. So, yeah, I wanna also kind of like clean up, no build. So we have the base in here, and that's what it is here. So essentially this thing, oh my god, I need to, oh my god, I'm in the wrong, like, my Git is so annoying sometimes. Should stop using Emacs, like, seriously, it's just such a waste of time. So run tests, okay, and here it is. So ends with example.wasm. Alright, we're gonna do this thing. Right, so I'm gonna put it like that. Cool. So here is another thing I want to do. I'm really sorry that I'm not good enough to solve this kind of problems like first try, and the stream ends up really boring and me staring at the screen for like 20 minutes or something. I'm really sorry. It's a really hard problem. I mean, the people who I'm apologizing to are already left, so it doesn't matter. I don't even need to apologize. Those people already left. So yes. I fucking hate this. All right, seems to be working. So yeah. There's just like a lot of people just look at the streamer. Oh, the streamer doesn't know what he's doing. Just leave it. Alright, so we have this bug. So we also have a lerp example and this thing. So might as well actually remove. Oh my god, come on. Yet an SF, I already explained that hundreds of times. Please. Seriously, I don't want to explain that multiple times already. So this is ignored. Okay, so if I run the tests, I don't think there are any particular problems in here. Right, and finally we can actually test the lerp on the on CI. We can test the lerp on CI, which is nice. So probably, do I want to clean that up? Maybe. Well, I keep thinking that I forgot something. Did I forget anything? I don't think I forgot anything. I think everything. Yeah, I wanted to check if I break. Oh my god. God fucking damn it. Okay, so if I put something like this in here. Okay, so it actually says that, yeah, it's not an expected output. The expected one is going to be like this. So, yes, cool. 147. Streams make it impossible to work on a real hard problems, holy shit. They encourage you to always pick something super easy and fun. If you try to like do something like that actually solve the problem, no, go fuck yourself. You can't do that on the stream. You can't do that. Like if it's not like something that is super like exciting and easy. I hate this job, seriously. I fucking hate it. It's not satisfying at all. Like at all. Alright, so, what I was doing, fix the dump F64 bug with precision overflow or something. I don't know how to call that, but yeah, let's try to push that back into the repo. Let's try to push that right into the repo. To be fair, like, you can retain the viewers even if you're having a hard problem, right? It's just like you have to pretend that you know what you're doing and always like act like a clown that you know. Look at that, look at my skills. But like, you cannot really do that if you're solving like a real like problem, right? You cannot do that. Maybe some people can, but to be fair, I haven't seen such people. Right. So yeah. It is what it is, and it isn't what it isn't. Right? It is what it is. Okay, so I don't want to finish the stream with such a mood, so I probably need to solve something easy to cheer me up a little bit. So we have a half of an hour, so. Alright, so it seems to be building on Windows, which is cool, right? So this entire stuff builds on Windows. So let me take a look. So do you test lerp? Does lerp have an expected result? Yep, it runs the lerp example and it seems to be having a correct result. I think it's kind of cool. I think it's kind of cool. I think it's kind of cool. So maybe I'm gonna make another cup of tea, and we're gonna try to solve something easy, maybe. So, yeah, let's make a cup of tea. All right. Finally, I have my Earl Grey. Still waiting for macOS, by the way. Still waiting for macOS. How everyone's doing, by the way, today? What are you guys drinking? Apologizes for macOS. Well, did you create macOS? I don't think so. Or maybe you did. Simply Pinhead is gifting Monty a sub. Thank you so much for supporting the channel. And Nuway, welcome to our epic virtual machine club, I suppose. Alright. So this thing seems to be working correctly. And let me actually put this into a thing. Doing fine, signed another contract for teaching people C, C++ and other stuff next semester this morning. Nice! Congratulations. I hope you enjoyed it. Yeah. I'm just an employed person. I know. Imagine Hotzenplot's teaching you C++. It's like Hotzenplot's teaching you how to use Windows. Yeah. Alright, so I'm gonna merge this pull request. I do quite enjoy teaching C and C++. Yeah, I'm thinking that I would enjoy working as a teacher. Alright, but I'm not sure how to deal with unmotivated people. Alright, because like on Twitch, unmotivated people, they either leave or they start acting like clowns in the chat and get banned. So it's quite easy. But if you like get in a university, for example, an unmotivated person, you cannot just ban them, right? So what do you do with them? What the fuck? Do you have to put up with them? What the fuck? No. I'm not patient enough to deal with these kind of people, so... motivated people don't come to the lectures training sessions. So... It actually... Well, in Russia it's slightly different, but yeah. So yeah, I actually live in a place, like I live in Akademgorodok, where we have the biggest university in Novosibirsk. So I was thinking maybe I can actually try to get into the teaching at the NSU, but I'm not sure how to get there. So you make them give up the class, at least that's what teachers do. God damn it, that's so cruel. Try streaming your lectures. Alright, so what have we done? So fix the dump. Oh yeah, I wanted to actually write a comment. Yeah, I need to write a comment. Tried to fix the problem in 168. Please check it out when you get a chance and close the issue if the problem is fixed for you. Boom. Alright, so, yep. Alright. Doesn't support nan and inf. Oh shit. So this one is gonna be rather difficult. Do not work on macOS. Constant folding. I need something easy. Like I don't want to do anything particularly difficult right now. Prime number generator. An unboxing example. Oh yeah, already fixed that. Alright, so I'm gonna go to the kitchen to boil up some water, and I'm gonna be back. Yeah, so people already start leaving again. Small break. Do I have to do? Yeah, let's actually do a break. I think the break would be nice. Oh yeah, I can merge you. Yeah, I forgot about your pull request. Thank you for reminding me. I'm gonna take a look at your pull request. All right, let's make a small break, and you guys have fun. Yo, what's up? Alright. Implement printing labels for call, GMP if. Alright, so sounds interesting. So the problem is that in a BDB, if you have something like call, right, it doesn't print the label of the function that you're calling. It prints the address associated with the label, which is not particularly convenient, right? We want to know what exactly is going on there. So yes, sir. And basically now hotspots actually fix that. So, and we even like have an information, right? We can distinguish different kinds of bindings. We can distinguish labels from native functions, and we can also distinguish them from constants, right? Even though they're located in the same like scope of bindings. Since we can distinguish them, we can actually print them in the debugger. Let's try to reproduce this problem without the fix, just to see what's going on. Maybe we can even see that somewhere here. So if I search for some of the calls, yeah, you can clearly see that. So the debugger prints like call 93, right? So, and 93 is just an address. But we need to print the actual names of the function, if it's possible, of course. So my tea is ready, so I'm gonna quickly pour a cup of tea and I'm gonna be back and we take a look at the solution. Hello. Okay, go. So, by the way, FreeFu, I haven't seen you for a while. Is everything okay? Were you busy with education or something? Or you got tired of my streams? I hope everything's okay. Alright, so, okay, cool. Let me fetch the latest stuff. I'm tired of your streams, I still watch the VODs. Oh shit, I forgot that I haven't uploaded to VOD channel for quite some time. I mean, I still upload the videos to VOD channel, I just don't release them. Yeah, I need to start releasing them yet again. Maybe I could automate that with Python, you know. Alright, so let's actually like do all. So did it fetch everything? So Python. Jiang heard word Python. Sorry. I mean, I'm referring to a meme about automating boring stuff with Python. I watched the Raylib streams and I joined them a bunch. Yeah, Raylib was actually super fun. I'm not gonna lie. And the creator of Raylib also saw the streams. He even, I don't know if it's he or she. So they even commented on the VOD itself. So I think there should be a timer when you want to release a YouTube video. Maybe. I'm not sure what you mean, but okay. Alright, so the branch is a print label colon jump. Okay. So let me take a look. So I also want to take a look. Nice. Look at that. Alright, I prepared for like a proper review and whatnot, and okay, cool. Yeah, I see. Very funny. Automating the interesting stuff with Python one. Soon? I think there is like a, you know, continuation of this book, automating boring stuff with Python. Why am I advertising his book? I don't understand. Yeah. Because it's such a meme. Yeah, beyond the basic stuff with Python, yes. There's a part 2. Electric Boogaloo. Cool. So I want to test how it's gonna work now. So we rebuilt everything. So we're gonna do build BDB, build example fib BM, and I'm gonna break a main and let's go. Oh, I need to run it. Sure. Look at that. Dump U64. It works. Automating shooting to the foot. In the foot. Okay, cool. Looks good to me. Thumbs up. Thank you for your contribution. Epic. Dump me 64. No, this is not what I meant. Alright, so let's fetch the latest shite. So what else do we have here? Do we have anything fun to work at? Yeah, that's what I wanted to say. Do we have anything fun, or is any fun is forbidden? Also, I haven't cleaned up the to-dos for quite some time. Let's actually do Snitch Purge, and let's take a look at some of the to-dos that could have been removed already. Semicolon, yeah, that one is already fixed. Oh, so Kolumbetko actually already closed this issue. Alright, so no way to disable echo. Fuck, okay, so this is from no build. God damn it. Alright, so, yeah. Include directive does not report location. Okay. There's no way to redirect the output of... Oh my god. Yeah. Alright. Let me take a look at how many things we removed. Like, we removed this thing, and we also removed this thing. Okay, so we can push that right into the repo. 99% of Brazilians don't know how to speak or write, so don't worry about it. I think it's true for like any native speakers, right? So, you think I know how to speak or write Russian? No. I can make Russian noises, right? That's what I can do. Bye bye, Hillspot. See you around. All right. Does not distinguish between labels, constants, and natives. All right. Error allocating. Oh yeah, we could implement something interesting, but maybe next time, because I'm already tired as hell. So yeah, I would try to like work on the, you know, error allocation thing and implement a proper like arena allocator. But I'm already streaming for hours, so I think it's too much for me for today. But maybe I could get through this cup of tea. I'm just contemplating whether I want to continue doing the program. Yeah, because implementing the arena is actually super easy. But I just need to think. I kind of want to stream a little bit more. Alright, so have you guys heard about region-based arena allocator? Region-based memory management. So yeah, essentially you create a data structure that allocates huge pages of memory, right? So maybe around 1 gigabyte, or maybe like half of a gigabyte, I don't know, it just depends on what you're trying to do. All of that could be customizable. Right, and these pages are linked together with like a linked list, right? So we have a huge pages, and they're connected together with linked list. So, and essentially, when you're trying to allocate the memory, what you do, you look at the current page, so you also keep track of the current page, and see if there's enough memory in that page for that allocation, and you allocate memory within that page, and return to the code that asks for more memory. If in the current page there's not enough memory, you allocate a new page and link it with the linked list. So yeah. That's basically the region-based memory allocator. What's interesting is that you can clean up all of the allocated memory in like one go, basically by iterating through the linked list and setting the size of the pages to 0. But you don't have to like actually delocate these pages, you can retain them, because then later you can reuse them for next allocations. So yeah. And what's interesting is that so the memory that you allocate grows, and then you can, when you deallocate everything, you essentially reuse the allocated memory. So, and it's very convenient for like compilers, for example, or for translators, like in our case. So yeah. Right now what we have like a very simple region-based memory allocation that is based on a single page. Right, we essentially allocate a single page, and if we run out of that page, we just crash. So that's what we do, and that's why sometimes like it doesn't work on some of the platforms, because we allocate like 1 GB of memory, right? And maybe on some platforms, in some particular situations, the operating system cannot find continuous region of 1 GB for the program, and it just doesn't allow it to run. So we had that happening on ARM 64. We had that happening on Windows. So yeah, it will be better to actually have like a dynamic region-based memory allocator, where you have like pages of the size, I don't know, 640 kilobytes or something, that can be easily allocated on all these platforms, and then just add more and more pages over time as you need them, right? And yeah, so this is basically what I wanted to implement for the virtual machine instead of the current allocator that we use. So does it sound interesting? Does it sound something that you guys watch me implementing? Because I actually implemented that region-based memory allocator for like several times already. So yeah. All right, let's go ahead and implement it. So maybe I will change the title. I'm gonna literally put this thing to the title in C. So it's going to be a new title. Nope. Question here. Arenas has fixed size. Junior, I can expand. No. I mean, the region, the pages, right? The pages have a fixed size. I didn't really read the paper, original paper, careful enough. But the way I do that, if I need to allocate a memory that is bigger than a single page, I basically, for that specific page, I allocate that size. So I let actually like bigger allocation. Yeah. So for me, like the size of the page is basically a recommendation, right? But if you need a bigger allocation, yeah, I can stretch the size of the page. So that means the page should not only store its size, how much it's filled, but also its capacity. And the pages, for my case, can have a variable amount of like capacity. And this kind of takes care of that problem. So I'm gonna start implementing, and we'll see how it goes. All right, so let me go. Yeah, so basically we have this error on Arch 64. So let's go. 154. So, and let me maybe start working on that on a separate file. So maybe we're gonna actually introduce the type called region, right? And as I already said, region is going to store its capacity. It's going to store its capacity and its size. Also, it's going to store a pointer to the memory. So luckily, we're using C, latest standard of C, and we can use a flexible array member, right? So essentially, this enables us with having structures of variable length, right? And all of the data in the buffer is located after the structure, and size of region is equal to the size of these fields, right? So basically, compiler guarantees us that we can access the memory after the structure. And essentially, if you want to allocate memory for a region of a particular capacity, what you'll have to do, size of region plus the size of the buffer, and then you can cast this entire thing to the region pointer, right? And just use it. So this is the kind of thing you can do. And also, we need to keep track of the next region. Since they are linked lists, you need to keep track of the next one. And since it's a self-referential data structure, we need to do the following thing. I need to put this region here, like this, and then I have to do type def struct region. Alrighty, and there we go. So this is a single region, right? So then we're gonna have an arena, that keeps track of the beginning of the linked list and the end of the linked list. So we're gonna have the first element, and we're gonna have the last region. So the first region and the last region. So yeah, this is basically the data structure that we need, and I'm gonna use the zero rule to basically allocate everything. So if you want to start using an arena, you would just do something like this. Arena and zero initialize it. Zero initialized arena is going to be a valid arena of the size 0, right? And all of the functions that work with arena have to take that into account. Also, I want to put something like capacity in here, right? So essentially, this is going to be the default capacity that is used when allocating a new region, right? But the actual capacity of the region can be bigger if a bigger annotation is required. If a bigger annotation is required, and for example, if you want to create an arena with a specific default capacity, you can do something like this, multiplied by 1000. There we go. So, and there we go, you have an arena. So the next thing we need to have is functions that allocate memory. So we can do arena alloc. It's going to be arena, and also you have to provide the size of the allocation, so how much you want to allocate. So it's going to be return null. And then we want to assert this entire thing and say that, for example, arena alloc is not implemented yet. It is not implemented yet. We're going to do the to-do here. There we go. So another very important thing for us is going to be actually freeing, cleaning the arena, right? So this is another operation that we need, which will go through all of the regions of the arena and set their sizes to 0, allowing to reuse those regions in the future. So we don't have to provide the size. So this one is pretty straightforward. To be fair, maybe I can implement it right away already. Alright, so essentially how you can do that, you can use an iterator, right? You can have a region iterator, right? And you start with first, right? You start with first up until iterator is not equal to null, right? And you keep iterating by doing iterator equal next, and there you go. You're essentially iterating through all of the regions, right? You're iterating through all of the regions. Then you can set iterator size to 0, and there you go. You cleaned up all of the pages. And another interesting thing, so we keep track of 2 pointers, first and last in the arena, right? Not using begin and end is disappointed with you. Do I have to use begin and end? I don't know. Well, the problem is, okay, end is an element after the last one, right? But we need to know the last one. So I'm specifically avoiding that convention because of the conventions, right? So end is the one after, but in our case it's not. It's actually last is the current one. All right, so here are the pages, right? Here are the pages. So here's the next page, and so on and so forth. So here is the first, and here is the last. Right, here's the last. Right, and we are using the last as the indicator of the current page. So after we went through all of the pages and we cleaned everything up, we should reset the last to the first to actually start reusing the pages. So that means after the clean, we should do the following thing. Last should be equal to first. Last should be equal to first. So this is the clean. I haven't actually built anything, so let me try to build one. The thing. Okay, it doesn't compile because we don't have a assert. And also we don't have an std. Okay, and it compiles. Alright, so basically it could be difficult to use this kind of arena with Valgrind, right? Because it will, if you don't free all these allocated regions, right, Valgrind is gonna show you that you have leaked memory. So we also probably want to have a function that basically frees all of the regions. I think it's a good idea. So we're gonna have arena free, right, which essentially frees everything from that arena, right? So, and after you're done working with the arena, you can do arena free like this, and there we go. So yeah, as you allocate more and more, it can create more and more pages and whatnot, right? And then you can free it, and your Valgrind is gonna be happy, right? So, all right, how are we gonna do that? I'm gonna start iterating regions as usual, right? To be fair, I think I should be able to modify arena, right? I should be able to modify arena, because after everything is freed, we need to set the arena to first and last to null, to indicate that arena is completely free and completely empty. So this is gonna be the iterator, then arena first, so this is the first, while iterator is not equal to null, and the iterator next, right? So what we're essentially doing, I think I need to first save the next, because if I straight up do something like that, I'm gonna be actually reading from invalid memory, which is kind of dangerous, so maybe it would be better for me. Oh yeah, and because of that I won't be able to do even this kind of shit. Okay, so alright, so maybe it makes sense for me to even do it like that then. So that's quite important. So this may require actually using while. Right, so while this thing, this thing, okay, and we want to retain the next, right? We want to retain the next before we try to actually free anything, because now it's actually a bad idea to try to access any of the next things. So this is essentially what we'll have to do here, right? And then after everything is done, we can set the first to null, and then we can set the last to null as well. Right? We can set the last to null. So there we go. We actually have free, and free also probably requires std_lib. Right? It also requires std_lib. Cool. So now we can clean it and we can free it, but the most difficult part is to actually allocate something, because it will require doing all of this stuff, right? So checking whether you already have the regions and whatnot. I think first thing you should be able to do, you should be able to create a region of a particular capacity. So let's try to do that. Region create. And so you provide capacity, right? So, and it should create the region of that particular capacity for you. So to do that, we allocate size of region plus size of capacity, right? And that creates us the region that we want to allocate. So it's going to be the pointer, there we go, and then we can return it. But we also need to set it up, right? We need to maybe zero initialize it, so we want to mem set region size of, actually, yeah, so we keep repeating this value, right, because I want to now use it here. So maybe it makes sense to introduce something like size t region size. So that's what it is, region size, and then I can reuse it like this. Region size. How everyone is doing? I'm really sorry that it's too boring. So, and we need to also set the capacity to the capacity that we specify here. All right. So region create. So yeah, that allocates a single page and of a particular capacity, and it also sets up all of the fields here, right? It zero initializes them and sets the capacity to whatever capacity was specified, so we don't have to worry about that. We don't have to worry about that. So now we are able to create everything. Okay, we have a couple of different situations here, right? We have a couple of different situations. It's when the arena first is actually null. Well, actually last, because we use last as an indicator of the current arena, right? We use last as an indicator of the current arena. So if the last is equal to null, that means like we don't have anything, right? We don't have anything. So we need to create it. But another interesting thing is that to make things consistent, like arena first also has to be equal to null, right? So if the arena last is null, first also has to be null, otherwise you have an inconsistent state of the arena. All right, so the next thing you can do, you can allocate the region or a particular capacity. You need to create region create. Right, but you need to create a region of a default capacity. So, and the default capacity is known within the arena. But here's the thing: what if the capacity is not enough to hold that size? So essentially, if the size is less than the arena's capacity, actually greater, we have to use this size as the capacity. Right, we have to use this size of the capacity. Otherwise, we're gonna use the capacity yet again. So you see, if you try to allocate more than there is a capacity for a particular region, we basically just use the size as the capacity. We allow these regions grow bigger. And what's cool is that then later when you clean the arena, the region of that size is not going anywhere, so it can be reused in the future. Right, it's not gonna go to waste, right, it's gonna be reused. Alright, so since this is a first thing, we need to set arena last to this region, so and arena first. Right, arena first, there we go. So now we have a first and last pointer pointing at that particular region. Cool, so this is a situation when the arena is completely new. Nothing is allocated, we're allocating the first page, and we are just setting everything up. Cool. Another case is when the size within the arena, right? The size within the arena plus the size is greater than the available capacity within that page, right? You see what I mean here? So you need to allocate a particular size. You need to allocate a particular size. You add that size to the current size of the arena, and if it's greater than capacity, well, you have to allocate another region again, right? A region again. So, but here's an interesting. You may have next regions. You may have next regions. So, you also have to do the following thing, like while this thing is greater than capacity, and right, you have next, right? So while you have next, you keep moving to the next. So essentially, if your current page doesn't have enough memory, instead of trying to allocate a new page, you may check out maybe there is a next page, because there could be next page from the previous allocations. And yeah, essentially we keep incrementing last until we hit when the next is null, right? And after that, we need to check this condition yet again. We need to check this condition yet again. And if it's still true, that means yes, we do need to allocate another page finally. We do need to allocate another page. Right, so we basically keep moving through the pages, Okay, so here is another page, and yeah, it's gonna be arena last. But I'm gonna actually set the next one to that region. Right, I'm setting the next one to that region, and then arena last that region. So yeah, I set it up, and then I give it like that. Cool. So yeah, so this is how we make sure that we have enough memory for that specific allocation in the current region. This is how we make sure. All right, so after all of these checks, we know for sure we have enough memory, so we need to just allocate it. So the result is going to be the following, right? You take the arena, you take the last, you take the, what is it called, the buffer, right? You have the buffer. So, and you do plus arena last size. So this is where you allocate the memory, right? Well, this is where you allocate the memory. After that, you take the size and you increment by the size that you allocated, so you just shift it around, and then you just return the result. Okay. So this is the whole allocation. But before you can do all of this, allocation, you need to make sure that you have enough memory, you have enough regions, you have enough everything. So does it compile? Does it compile? It does not compile because we don't have memset. Memset is located in string.h, right? And yeah, there we go. I want to be able to print the arena, like a summary of arena, just to see what's inside of it, like its general structure. Because now I want to be able to test this entire stuff. So let's create something like arena summary. Okay, so how are we gonna do all that? I'm gonna just iterate through the pages of the arena. It's gonna be a region iterator. So arena first, then while iterator is not null, iterator next. So and how we're gonna be printing all of that? So the way we're gonna be printing all of that is gonna print f, and I'm gonna just print the size, the current size, and the capacity, like this. Right, so the size and the current capacity. Yeah, so it's gonna be size and capacity. There we go. And after that, we're gonna print the new line, right? So it's gonna be in a single line. So we're gonna print all of the pages in a single line. So, and I guess in the case of like empty, if arena first is equal to null, we're gonna just simply print empty. We're gonna just simply print empty. So, and if I try to print the arena now, let's see what's gonna happen. Alright, so I'm gonna try to build everything and just run everything, and yeah, so right now the arena is empty because we didn't try to allocate anything. Okay, so let's try to allocate something, I suppose. Let's do arena alloc. So first of all, let's set the default capacity of the page to something smaller, to something that will force it overflow. So it's gonna be arena, and let's allocate, let me see, 35, right, let's allocate 35 bytes, right, and after we allocated 35 bytes, let's print the summary of the arena. There we go. So as you can see, it allocated a new region with the capacity of 69, right, with the capacity of 69, and it put that memory there. So we can try to allocate, for example, 5 bytes, 5 more bytes, and there you go, it actually filled it up even more. And now let's try to test it on its age. So I'm gonna allocate 29 now. So yeah, it fit the memory perfectly within a single page, and it didn't overflow anything, right? And it didn't force like another allocation on the next page. So let's actually try to allocate yet another byte, which will hopefully force it to allocate another page. And as you can see, it did allocate another page. Cool. So everything seems to be working correctly. So another thing, let's try to allocate something that is bigger than the page, right? So in this particular case, it will force it to basically abandon this page and create a new one with the size of 70 and completely fill it, right? So let's actually try to do that. Yeah, there we go. So essentially, it tried to allocate 70 bytes, but it didn't have enough memory for that, so it created a new page and completely filled it in. So you may think that this is a waste of memory, but in the long term, I think it is not, because at any point you can actually clean up the arena. You can do arena clean, right? And it essentially doesn't remove the pages. It basically goes through all of the pages and sets their size to 0. So all of these allocated pages, they're still reusable. They're still reusable after you clean the arena. So essentially now, if I try to allocate, you know, arena alloc arena 35 yet again, and then take a look at the summary, right? It's gonna be 35. They can have arbitrary sizes. Yes, who said they cannot? Who said they cannot? I don't think anyone ever said that they cannot. And my solution essentially, like, if the allocation requires more than the size of the region, just create a bigger region, right, for that specific case, and keep track of the capacities of the region. But we're looking at a very specific case. This is absolutely unrealistic case. Why the fuck would you have a page of the size 69? So I do that just to check overflows and whatnot, right? I want to check specific cases. In reality, you're gonna have a page of a size of a fucking gigabyte or something. So this is 1 megabyte, so 1 gigabyte. And here are all of your allocations within that gigabyte. Right, so allocating a next page is going to be a super rare event. Okay, maybe 1 gigabyte is unrealistic, so maybe in our case we're going to have something like 640 kilobytes. But even then, right, even then, it's just like, yeah, so it's actually pretty dumb. What happens if you look, will the regions? Yes, they will. That's the point. So, yeah. So that's the arena located. But maybe, yeah, I'm not sure if it was interesting, but this is what I want to use in BOSM. But yeah, now I need to actually integrate all of that. And integrating all of that, it could be actually completely difficult. Actually, on something, yeah. Source code, okay. Let me gist. Okay, so let's call it C region based. There we go. So yeah, and essentially the cool. Why would you even do this entire thing? Why not just use malloc, right? The thing is, you can basically have algorithms which make a lot of small allocations, right? They make a lot of small allocations, and it's too much effort to keep track of all of these allocations. What you eventually want to be able to do is to just allocate as much as possible, and when you're done with the algorithm, you want to deallocate everything at once. And not only deallocate, but then later reuse that memory that was allocated. So it's almost like using this kind of allocator is like using a garbage collector, but you decide what's the garbage and when to trigger the garbage collector, right? So essentially you know that you have a bunch of objects with a very specific lifetime, and you know exactly where the lifetime of all of these objects ends, right? You can just place them all in the arena, and when you know that these objects are not needed anymore, you just clean the entire arena, and then you can reuse that arena for something else. It's actually extremely convenient. So yeah. And it's quite important to implement it as a linked list of big regions and not use realloc. Like, don't implement this entire stuff as realloc, because realloc may invalidate all of your pointers. It could be possible to reuse that space. Yes, that's the point. So this entire data structure is designed to let you reuse these regions. Right? You allocate these regions with different sizes. They may have different sizes, and then you can just reuse this by calling clean, which cleans everything up, and just you can reuse it. All right. So for more information, you can actually read about that in here on Wikipedia. It was actually explained quite well there. And I think another place to read about it is probably this page. Okay, so you can actually probably Google up this entire thing, just PDF, because it's definitely available on the internet for free. It must be. Scholar. Really? It's not available? God damn it. But, I mean, you know how to get it. Yeah, so this... it's 1989! Seriously, it's such an old... It's... Oh my god. It doesn't even explain anything particularly revolutionary. Holy shit. Anyway. Would it make sense to check from the beginning of the list? Well, that kind of defeats the purpose of a fast allocation. You know... And as I mentioned, the situation when you have the size of the page of 69 is unrealistic. It is very unrealistic. This is a very specific size just to test corner cases. You're not gonna have such size. Your size is gonna be huge. Your size is gonna be huge. So none of that will matter. None of these cases in reality will matter. Seriously, come on. So I just created this capacity just to test things out, like these specific cases and whatnot. You're gonna have huge pages, just don't worry about it. Don't fucking worry about it. Seriously. Yeah. Anyways, so I'm not sure if it was interesting or not. Alright, I guess that's it for today. Yeah, we're gonna try to integrate this region memory allocator. Tomorrow we're gonna continue working on this thing, right? Working on a virtual machine. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all tomorrow. As I already said, tomorrow we're gonna continue working on it. Check out our schedule for more information on different projects we're working on, right, on different projects. Check out our VODs channel where we upload the recordings of the streams. And also check out our Discord server for offline discussion with the community. So yeah, thanks everyone for watching. Love you all.